Firdaus, can you hear us? Firdaus, can you hear?
I can hear you, sir.
You have share option or not? Presentation share option or not? Check.
Sir.
Visible. No problem. Everything is fine.
Okay, sir.
Okay. Go to the first slide and keep it there.
Okay, sir.
Or you can show it. Leave it and show your. Leave
Sure,
it and
sir.
show. Ranbir?
Yes. Good morning, sir.
Morning. You'll take care of it or what to do?
I think, sir, today I was thinking that you take up for the introduction for the Firdaus.
Okay, fine, no problem. Okay. We'll start at, we'll see. Okay. Ranbir will wait or will just start blah, blah, blah. Well, Firdaus will start. Let him. Firdaus? Hello, Firdaus?
Oh, sir, I forgot to
Yes, sir.
unmute.
Yes.
I was suggesting that since participants are joining, maybe 5 minutes.
Sure.
5 minutes.
Sure.
Okay, 10 times we will start.
Yeah, in between, I think, Firdaus, I think you can share the screen.
Just give me a couple of.
It's working at if those kids like, or you
Sure.
show your face.
Give me.
Whichever is comfortable to you. You have to
Uh,
introduce.
give me a minute. Please allow me a minute. I'm just switching my machine from one machine to another.
Huh? Okay. Firdaus, can you share or come
Yes.
enable your
Yes.
video? Enable your video.
Yes, sir.
Okay. We can start. Good morning to all of you, panelists and the participants, and some of the participants. Like today is the last day. We are starting our first sessions. Today's speaker is special for me. He is as Dr. Firdaus Ahmed Barbuya. He is at present Associate Professor Science and Engineering and Associate Dean R&D at IIIT Guwahati. He did Bachelor from Jodhar Engineering College, Dibrugarh, under Dibrugarh University. Then joined in IIT Guwahati as engineer, tech, joined in PhD. But in the meantime, he went to some famous company you know, now it is Paytm, the global logic. And he was there since 2009, 7. And I shouted on him and he came back and completed his PhD. After completion of his PhD, he joined in IIIT Guwahati, and he is now associate professor and dean also, R&D. He is second in command almost in IIIT, and he is working on security in cloud, SDN, and NAP. Also working in biometric security, security is in Internet of Things, and intrusion and prevention systems. As intrusion and prevention systems comes in, he also started working in social media analytics. He has several funded projects. He guided few PhD students and published good number of journals and conference papers. And hope he will talk about the fake news detections and in social media analytics. Dr. Firdaus, now hand over to you. Please start your session.
Thank you, sir, the introduction. At the beginning, I would like to acknowledge your contribution in what I am today. Thank you very much for guiding me, bringing me back from industry, teaching me how to do research, and eventually whatever little I have done, possibly because of your shouting, your guidance, your love, everything together. Thank you. Good morning, participants. I'm Firdaus, and together we will go through the detection mechanism of fake news on online social network. I have tried my level best as systematic as possible. Please forgive me if there are like some jumps here and there, because I'm also not a where I don't claim myself to be an expert. I have started working in this area for last couple of years, and published a few. Still learning a lot, and I expect today that we will interact more, and even I learn from you as well. Allow me a moment. It seems the screen has closed or something. So here is the outline of my talk. I'm trying to keep it academic, and also at the same time a little bit of how things are done practically, or what is there and what is not there. I'll start with the problem overview. What is the problem in hand to detect fake news? What are the current solutions we have? Limitations of these solutions, and why comprehensively we cannot detect fake news. I'll give some concluding challenges remarks, and then followed by of our solution. And please feel free to give constructive suggestions, criticisms to our solution. So let's talk about fake news. What does it mean? How it affects day-to-day life, and what is its significance? I mean, what is the danger that it can pose? One of the foremost example I can give about fake news that led to war, and the loss of life was possibly in millions. I'm sure some of you can guess it. It's the Iraq war. Although at that time, I'm not sure whether the word fake news was around or not, but um, whether it has been named or not, but the fake news was present. What has happened in 2003? That a lot of publication came out supporting the claim that in a country called Iraq, there are weapons of mass destruction, and it is very dangerous for the world security. So world leader got together that something has to be done. and then finally a war, and then at the end nothing could be found, and then it has been figured out that the image that has been shared as a nuclear plant was a edible well something facility, all of that. I mean, I don't want to go into the politics of that, but the history or the consequence of fake news is something like it can lead to even a war and destruction of millions of life, just not like one or two small incidents here and there. So um, as a human being, we should be very, very cautious about fake news. And in the national interest also, we have seen effect of fake news in our own country that has led to law and order problem, riots, loss of life, etc., etc. And we all are sure, we all know the effect of it. Question comes like, what is a fake news? In a few words only, there are a lot of academic definitions of fake news. I'll come to one or two, but I would like to say that it's this false or incorrect information. And why give a false or incorrect information depends. The purpose is to affect the perception of people. You want to change the perception of the people. You want to create, I mean, somebody wants to create animosity among the people, or somebody does it just for fun. Somebody does it for some commercial gain. All of that are possible. Okay. Please forgive me. It is taking a little time while changing between the slides. It doesn't. Okay. So what is the challenge now? And if the fake news is in some limited source, let's say in newspapers or a few articles, possibly it is easy to police, monitor it. But just imagine the scale at which it is happening today by leveraging online social networks, which has provided a very fertile ground for emergence and first spread of rumors or fake news, false informations, etc. We every morning, I'm sure when you wake up, and I'm sure all of you are member of many WhatsApp groups, and you will see WhatsApp forward. This is pandemic time, and I'm sure many of them are related to pandemic. This has happened, that has happened, has not happened. Some of them are anti-government, some of them are pro-government. And then if you just try to do a fact check on them, you'll find many of them or most of them are actually fake information. But then when you look at them, it's very, very difficult to tell whether they are, with your I mean, without using any mechanism, it's very difficult to say whether they are fake or real. Okay. And by now, we all know that it can harm our day-to-day life or the real life. So there's a problem in our hand, and we need a solution to the problem. Okay, so let's go a little bit of bookish definition. So what it says is, I'll quote and unquote. Fake news is where individuals or organizations intentionally publish hoaxes, propaganda, and other misinformation and present it as factual, that it appears to be correct. So this can include blogs, social media posts, and media releases, and much more. Morphed images, morphed statements. A few days back, some statement came out about Mr. Ratan Tata, saying something, doing something. Okay, I won't go into the nitty gritty of it. I have seen that on my WhatsApp, forward. So then, even why not we leverage? I will talk about it a little later in my talk. That what we have done, that the WhatsApp platform itself to find genuinity of the posts, because the biggest spreader these days is WhatsApp forwards. The number of forwards that are happening day to day. Why people love WhatsApp forwards, because it directly goes to the phone of the person. If somebody shares it on the Facebook, it is the user has to log on, probably scroll through many things, and it might. But fake news spreaders, they just love WhatsApp because it's very high chance that the person will see it. And include the satire sites. Many a times there are publication houses who publish a satire, or they are like jokes. There is a famous website called Faking News, okay, or even mainstream also publish some news where they write a disclaimer, very thing, and it is out of humor. Okay, when such information is given, it should not consider it as a fake news, because it in a legitimate manner. Okay, but then if somebody takes that news and remove that declaration where it says that this is illegitimate, factual changes something, again it becomes fake news. Now, typically, whoever creates the fake news should be punished. So, what do we do? How do we feel a post on social media? It might have been forwarded like many hundred or thousand times, or maybe even million times, and how one can trace back, like who has actually started it. Forwarding something which is hateful, which can create animosity, between community, has false information against an individual, organization, etc. All of them are, but many times the people who forward, they themselves do not realize what they're doing. They just think that it came from one of my friend in WhatsApp, so it must be true. Okay. Also, there is another point that is very important, that there are certain articles that are written from editorial standpoint. It is a view of somebody, okay, and it is not claimed as news. Those cannot be classified as fake news. If editor of a newspaper says that, okay, this is what is likely to happen, if it doesn't happen, that should be fine, because that's included in freedom of expression or whatever. And again, the other problem is that the definition of fake news can vary from geography to geography, because what is allowed in India may not be, or what is not allowed in India may not be true in other countries. But more or less, the content or broad agreement of Facebook is, fake news is there, and this is what the definition says. Okay. What is the intention behind this? So, intention behind, whose intentionality is one of the goal for us to figure out. Who is the creator of the news? Government, for example, the weapon of mass destruction example. It may be the press. Who is the purveyor of the news? Who spreads it? Maybe the press. maybe the social media, it may be you, me, or anybody. And our, the problem at hand is to capture the intention and use some kind of a technique to analyze it. Okay. Till now, if anyone has a question, please ask me. Feel free to make it interactive. Otherwise, it will become a one-way deliberation. So some of the examples are like Sweden signed the deal, member of NATO. Then CEO made that President of United States has said, which has, so the Pepsi stock tanks. It had its big significance. The fake news became so popular. Sweden signed NATO. Okay, so I have at least one question. I will address it very. Fake news and possibly hate speech. So even some world leader started talking about it. Stuff. The difference between hate speech. Hate is something offensive that is said about someone, or some individual, some nationality, some race, some religion, etc., which has and that may not convey a news. Okay, so that's basically sometimes or rather that's mostly targeted by for example, somebody says something against third gender. Let's say hate speech. Okay, I'll come to the second question. That does it include NLP or natural language processing? We will see to it. For example, somebody says that okay, XYZ religion has custom as a very bad custom, or this XYZ religions, this person or this figure is such and such. And we have seen recently, what has happened in Bangalore. That's basically hate speech. News is more about giving an information which is false. So it may not contain any hate statement. Let me where do I see the question? Okay, the questions are coming in chat box, I guess. Just allow me a moment. Okay. So fake profile and fake news. See, fake profile may be a way of disseminating fake news, but I mean they may be interrelated, but not necessarily. And how do we distinguish between intentional and unintentional? Difficult task. There are some propositions already. We will we will show you, or rather about it. Essential for us to counter or friendly neighbor attempt to influence the border population through fake news. I'm not sure what you want to ask, but if you are asking like whether you should counter fake news or not, totally your prerogative. But at least don't fail news. And from I believe we all are faculties here, so I mean at least we should try to see that we are not affected, and if out a way how we can detect it. What about body original news of a newspaper and circulate it. Depends. If somebody modifies the original news article, let's say somebody rephrases it, I don't see any harm in it. Somebody intention was there are two people in the picture. One person has been removed and the other person is falsely implicated or something, or there is a third person interpretation grafting that is done, or not only under fake news, but it is a case of for grafting, graft as well. Okay, so next slide. That there are defenders of misinformation as well. So how do we detect misinformation? Anyone, I'm not sure, we can unmute yourself, but if anyone can tell me your experience, how, if you have ever encountered a fake news and how you have detected it. Yes, Putin Lion, yeah. So you can check, there are many fact-checking websites, right? You can go there and you can paste the text or the source, and you can know about the validity of it. Okay, and yes, if it is a Shantu, nice yeah, that reverse image search. If there is an image, you can do a reverse image search and try to see. There are many cases like images of Pakistan, images of some spread some disturbance in India, in our own country or in our own state even. So during the time of CA protest, many such things happened. So if the image remained intact, possibly you can do a reverse image size. But if somebody has mutated the image heavily, for example, change the entire background, then reverse image search kind of becomes very, very difficult. Or almost, at least the Google advanced search will not do. Okay, so how this fact checker works? There are two approaches. One is human intervention, that they have humans or there are editorial staff members who actually looks at the content, tries to cross verify it across multiple and come to a reasonable conclusion. Okay, but one of the irritating fact I have seen is that the moment you start looking at such a video or an article, feeling whether it is true or not. Okay, because that's their business, of course. Yeah, there's some more question. PIB, Press Information Bureau, has some fact checking. Yes, let's say those bodies can do fact checking of very high spreading fake news, which has larger impact. But many of the fake news are like, they reach a lot of people, but they are not noticed. Maybe they reach 1 million, but they do not start trending. Okay, so many of them are overlooked. Someone said, besides spam checker, relation of personality also matters. Yes, it does matter. Let me check. I have half an hour. Maybe I'll have to expedite. And the second approach is using algorithms. What kind of algorithm we can use? Can we use computer science? Somebody says NLP. Can we use the power of NLP to detect? Okay. So here is a word of disclaimer. I'm not an NLP specialist. So I use NLP as a tool rather than I'm an expert of NLP. Okay. For many of us, the way any libraries of computer science, the way it is for me, NLP is like that. I'm a security. I'm trained in security networks, etc. but I'm not a trained person in NLP, so I may not be able to give you in-depth information about NLP. So whatever I have little NLP I have used, I will try to give you that information. Okay. Some of the current solution. So the first type of approach is like linguistic approach. Various categories in it. You look at data representation, deep syntax, semantic analysis. Semantic, you try to get the meaning, rhetorical structures, classifiers, etc. So there are some linguistic clues that are taken out. I won't get greater details of it. Deception indexes are created. Basically, you get a score out of, and I'll talk about the mechanism a little later about the from the given text. You standardize or average it with the deviation, that how much it deviates from other sources. It is real or fake. Also, accuracy of textual self-description is taken into consideration. Linguistics measures, run through some algorithms, find the indices of the words, frequency that occurs. Okay, classify into 3 categories, like emotional linguistic cues, whether they have fewer sequences, whether fewer exclusive words, increased motion words, etc. A lower overall word count. Typically, those are some of the symptoms, but they may not be correct. Many published, for example, a breaking news, they publish with very few words. Okay, not a full of mechanism, but many a times it helps us figuring out some of the there are some results. Maybe I'll skip the results because it assumes some preliminary knowledge about, not sure, like how do the whole audience stands, but tell you that if you look at the the result column, the distributions, they are not very encouraging. They literally struggle to detect. Okay, so the other thing is that whenever you look at such information, the way uh, the current paradigm I have discussed, you miss a lot of connections, because they are analyzed per se in an independent, void of any links with other data. Many a time, the fake news are not very straightforward a chunk of text. Okay, so there are embedded images, there are files, there are links. Okay, and there are spreading mechanisms. So from a text, you may not be able to figure out like where the source is, or from where I can get the source. So the other approach is called linked data. Basically, you try to link the text you have got or the sample you have got with the other surroundings. Okay, and leverage the existing knowledge base. Let's say, for example, human knowledge. In our case, it will be like artificial or intelligence, right? And publicly available structured data, we look at it and try to figure out they are fake news or not. For example, we may look at like there are a lot of fake news around Barack Obama. He will not quit US office. He has this religion, he has that religion. I mean, those are all politically motivated. I mean, he didn't go to school, he didn't have all of that. You search fake news around Obama, you will find it. Okay, so one of the fake news was like he is a Muslim. Okay, before his election campaign was, he was kind of like, some people try to take the advantage by spreading some false information about it. So if you try to look at spread, walk through like where it originated, what is the network of it, you can actually you can actually figure out like where the relationship came and where it has happened. So he had some relation with some university, some professor, some and which leads to the question that he is mostly of linked representation. You can figure out the link. So now one of the okay, this is a well research, and this slide is directly a library. So tells a few methods. The first method, it says that read past the headline. Okay, so one of the common characteristic that has fake news is created. I'm not saying all, but many of them doesn't put that effort in the content part of it, but the headlines are very catchy. The headline, but read through the entire content of it. Okay. The second mechanism, it says that check who originally published it. Any fact-checking website, if it see that the news has been some very reputed media houses, let's say Times of India, The Hindu. So it has more credibility than some ABC portal publishing it. I mean, yet to establish credibility or not so established credibility, right? So that gives us a lot of information. Follow links and check sources. I mean, from where the information came, how it propagated. If we can follow that, it's quite a lot of information. Okay, beware of many times. We are biased. There are biased. The way we train our algorithm, that gets biased. Just don't. I mean, we'll have to be careful that whatever we just want to see should not be like that. It should be based on facts. Another easy way is that if you think that a news may not be true, check it. So out of 10, if 1 says that it is true and 9 says that maybe the again so there not be a complete confirmatory when things are not that easy, but there's a greater possibility that the majority may not be lying. But in today's world, it might be reverse also. The majority might be lying, and 1 or 2 guys might be telling the truth. Okay. Of course, a word of advice like think before you share, right? So all of us know that ethics. So I think I'll skip this. I enough about it. So the human strategies, basically what we know, how these strategies are used to detect fake news, that itself translates to fake news. I mean, detection by machine. Pretty busy. Sorry, I could up. I should have actually. It's looking very bookish. So there are some fake news challenges, detect mechanisms. I think I'll the strategy simply 3 goals we have. One is that fake news detection. The other is to check the veracity of the fake news and estimate. We call it as stance, okay, of 2 texts of relative type. So that's the strategy. Okay, again a little bit of more formal definition. Detection approach, that if you have an input a body text either from some news article or from multiple. What should be the output? Classify the output should be like the classification of stance of the body text and the claims that is being made. We can actually classify into 4 different categories. So there was a fake news challenge. There's a fake news challenge website called fakenewschallenge.org. So it's as per their classification that what you can do. Either you can agree that text body text goes with or agrees with the headline, disagree, the body text disagrees with the headline, discusses that it discusses the topic, but it doesn't take a position whether it is true or not true, and unrelated that the body text and the headline doesn't match. Some examples like body text which are correct, which are not correct. Examples, so I'll talk about it later. This is directly from the fake news challenge.org. Okay, so what are the just give me a moment. Automated fact checking is nothing but a claim validation. Okay, some some well established news houses also falls prey to it. For example, the Daily Mail claimed that some flooding has happened in Palestine. Al Jazeera reported it, and the Jerusalem Post claimed that it didn't happen that way. Okay, so and then what has been seen is that in that part of the Israel there are actually to release water. So things can be as dicey as that. Now, if you talk about taking information from large media houses and deciding, see, the Jerusalem Post is also credible, Al Jazeera is also credible, the Daily Mail is also even more credible. Now, where do you take the stand? Okay, so then there comes like fact checking at a different level. What are the fake news detection system available? Yeah, I'm talking about it. Give me a few moments. Okay, so here it is. One of the very well published or well one is by publication from Helensky and Gurevich, and it is from the Technische University of Deutschland. So what they say is that you have an NLP pipeline, you feed the claim into it, and you have a large corpus on the web from source information. You need to extract evidence from it and look at all these evidences, and verify along with these evidences, and you give a verdict. This is one of the generalized or one of the well mechanism of finding fake news. But we'll see in a while, like where it doesn't work or where it may not. Another mechanism again proposed by the same authors is like using LSTMs or even by LSTMs, etc. That you look at claim, or you say not in evidence, you look at some evidence, and then you use LSTM. You use word embeddings. Of course, things are I'll presume a little bit of knowledge into machine learning, because in 1 hour we may not be able to give a tutorial on LSTM or by LSTM or stance learning, etc. But we have mechanisms to check these kind of claims. Okay, but what are the limitations, of the current solution? One, information is so large that you want to validate, it might take quite some time to validate. The information is mutating so fast that if you build a rule, a model out of all this, jungle of information, it actually becomes obsolete very quickly. Okay, we need a mechanism which can, at the same time, after 3 days, whether, or after 3 hours, that whether the news was fake or not. Okay, and it has to operate in retrospective manner. So that's again, it's a very time sensitive matter, and that creates a severe limitation to what can be done and what is available. So I mean that's the reason a rumor, when it spreads quite a lot before it before we can detect. And one of the mechanism, or one of the goal should be that latency aware. We should be very, very careful about the latency we take to detect. Now the latency may be for various reasons. One of the reason is like you just don't have the rumor, it is spreading, but your detection mechanism doesn't happen. It's not necessary that like it will reach you automatically. So how do you get it actually? So if we want to get it, we need to go to the source of it. What we have done is not something like very, very out of the world. Someone is saying PPT not visible. It may be related to your bandwidth. Please check with yourself. Can anyone please confirm if my PPT is visible?
It is visible. It is visible.
Thank you, sir. Thank you, sir. Okay. So anybody who has a problem, please check your bandwidth. Okay. So yeah. So these are time sensitivity issues. The other issues, like we use, I mean, any technique use clustering of data by keywords using ensemble methods or combine a user and propagation, content-based feature, etc. Computing these features is efficient, but what it needs is repeated response by other users. Okay? And again, it results in increased latency between the publication. Now, what is the current state of art? Some of the publication that happens around NLP, specifically position of computational linguistics. There are big conferences like Semibal, SONAM, etc. And if you look at the state of art, accuracy is close to 70%, but then that accuracy is also in a very limited set of data. Another people used to take is like scraping or getting amount of data from social media. Some specific problem that has happened in last 3-4 years, or maybe 5-6 years, where some elections got influenced by social media. But there is a company who did, all of you can name what is the company in US who played a role in election and did something. So the social media platform, they changed their policies. Now they don't allow you to download tweets or post in an unlimited manner. They actually put you a time limit. Now, let's say for the first hour, you may be able to download like 20 tweets. Next hour, or rather first minute, maybe 5 tweets. Next minute, it will be reduced to 2. I mean, and they will keep on throttling it. One side, like there, you cannot get even the. How will you detect like what is going on. There is ambiguity in the language. There are many deceptive techniques people are using. Okay, then again, if you talk about offensive, that is offensive matters, that prerogative changes country to country. There are many crude things which are not very acceptable in our society, but it is perfectly acceptable in an European society or an American society. Okay, issue that, emoticons and symbols. Many a times, people change the meaning of something by using some these emoticons or emoticons or symbols, right? And that leads to in classification, because one or a few characters are changing what it means. Some of the other drawbacks are like most models are specific to some network or some data sets, and they are heavily biased. Okay, and they identify only a very small percentage of fake data. Obvious reason is we need more features into it. So there are of late, techniques like deep learning came in the picture, but at times the data size is so small. Just think about the Twitter, a tweet. Sometimes making out like what is it is simply like the models doesn't actually or models are not good enough for that. So there are technical limitations as well, like which mainly concentrates on two specific problems. That how can we detect signal of misinformation as early as possible, as I said, like with very low latency, and how can we improve the accuracy? And both are mutually exclusive. If we try to do one, the other suffers. Okay, so one of the challenge is to find a middle path. I think enough of all this. I talked about it. So let's talk about like what we teach. So actually built ML model of text analysis, fake news analysis, image, video analysis, a lot of such information we put in inside using we didn't rely on only one data sets, like, but as many as we could got. Some of them are openly available. Some of them are sources from law enforcement agencies, etc. Some of them are from our users' annotated data. Okay? Um, we have built reports, hashtags, monitors, tracing, etc. And on top of the paradigm, we have built a WhatsApp bot also. Of course, there is a website. There is a website. How WhatsApp bot, browser plugin. So basically, there are three mechanisms, and all three parallelly works. I'll show you how it works. Okay. So typically, our application is divided into three different parts. So traditionally, you can visit the website. I wish I could show a demo, but I don't think time will permit. Nevertheless, if anybody is interested, you can send me an email. We have not published the work yet, so we have not opened it, but I can send you a link where you can test our system. You're more than welcome to do that. So in the website, of course, like any fact checker website, you can paste the text and you can say search, and we will tell you, and along with sources that why we believe that it is true or it is not true, and we will also tell the which mechanism we have used for that. Okay, we have developed a Chrome extension. Why we thought about it? That first problem is, like, if we want to look at the tweets, Twitter simply is not allowing us. If we want to look at the Facebook posts, simply I cannot reach the post because I am not that person, or it's just out of my network. So what the Chrome extension will do, that if I have the Chrome extension, or if my Chrome is on the browser of whoever wants to verify fake news, automatically the texts are rendered on the browser. So the texts are available, so we can take the text I find law enforcement agencies are very interested. They have started, at least Assam police have started looking at it, and police research organizations, they are also evaluating it. Yeah. So third part is like we have created a WhatsApp bot. As we know, we need to be very, very latency sensitive, and where we can get this information, because as I mentioned earlier, and all of us know that most of the forwards comes through WhatsApp. So if the user has a mechanism to validate it inside the WhatsApp itself without going to, many times you won't feel like going to a fact checking website, paste it, why I should do that. If it is available within the source itself, then it's very helpful, and people can quickly. These are three broad areas where we have we have contributed. So the Chrome extension, basically what it does, it looks at texts. It can also block offensive words. It can act kind of a censoring mechanism, report objectionable content, and it can do the analysis, fact analysis. It can also do an image search, a reverse image search, and find out like whether it is a morphed image, real image. And then it can also do a fake news. You use the Chrome extension, and it can block the fake news sites, parody sites, misleading journalistic sources, etc. Kind of a screenshot. If you can see the leftmost image, right? So there's a small icon you can see. If you highlight any text, this icon will appear. Click on this. It will actually give you a on the frame. It will give you information in a layer that what are the sources, and it gives a conclusion like why it is true, why it is false. Yeah. So here is the schematics from the plugin or other sources. We extract the text. We put an offensive filter on it. Forward the result and tags 20 results of Google Advanced Search around that. Okay, and compare both the claims and the NLP model. We associate, or rather, we multiply the associated credibility. We are of fake, real, natural, neutral, and unrelated. These are the four categories we classify. Similarly, with images, we do reverse image search, and we see whether it is a morphed image, and we check whether the result generated, and we tell the original image whether correct date or timestamp, etc. Some of the solutions are very simple, and as I said, we have not done any rocket science. Algorithms only. I think I'm already exceeding my time. I'll be quickly finishing it off. So yeah, why we created WhatsApp. So there is to our registered number, you can image, video, etc., and our backend checks the system whether fake or real. It also provides like daily list of viral fake news. If you want to know like what are the viral fake news in my locality, or in my country or in my region, which report backs to us, and which helps us in improving. We get kind of an annotated list. We can verify it again, and system. Some of the screenshots, like what the WhatsApp bot look like. Yeah, the technology stack that we have used is like React framework, JavaScript, JSON, HTML, Bootstrap, both AWS and IBM Cloud APIs, etc. And we
Hello?
Yes, Amazon, right? And we have frameworks. You can learn it at any time. We have also used very simple mechanism to identify files. For every unique file, we have used MD5 mechanism, MD5 sum, and we store hash value. We compare the hash value with other files, whatever we see of a fake news around, because many times the fake news is spread with the image. The news is embedded in an image, or even it can be a PDF or a document, etc. So we can quickly identify. That saves times. It's much more efficient. So simple. The file in a, we give the file to an input algorithm. We look at the MD5 value, and then we create the hash code for the file. That's all from my side. Thank you very much for giving me opportunity. Thank you, Professor Nandi. Thank you, Dr. Ranveer, for the opportunity, and thank you, ISEA.
Well, Firdaus, you have given a nice talk. At least the implementation point of view, and you are able to come up with a new product.
For yes, sir.
Firdaus, can you hear me?
Yes, sir. I can hear you.
It's a nice information, and you have propagated a lot, and you have clarified a lot of points, and you developed a product, and product is available for the law enforcement agency, appears to me.
Yes, sir.
Is it
yes,
yes?
sir. Yes, sir. Currently, only law enforcement agency is using it because we are learning from them. We are fixing our issues, and also the publication is pending. And once we get a good amount of confidence, we have a plan to open it for the public. But while opening it for the public, we'll incur heavy cost. So we are looking for funding source as well.
Okay, let us go for the some questions till
Sure, sir.
what you have answered. You can see the questions, or I will read it. Those?
The other
It is Q&A and chat box.
mostly in chat box. I do not see anything in Q&A, sir.
No, Q&A is good number of there.
Okay, sir. I'll look at that. So there are 3 questions in chat box. Let me finish. Yes, sir.
Complete one after another. First chat box. Anything is there?
Sure. So someone has asked, like, scraping tool for data from Facebook. As such, if somebody sells you telling that it is a scraping tool for Facebook, don't believe that. There are some open source scripts available. Feel free to use them. But many a times you will find that most of them doesn't work. The reason being Facebook policy has changed. Some of the very active GitHub projects are there. If you want if you want the links, right now I do not have readily. Send me an email. I'll send you the links where the scraping scripts are pretty good. But scraping is mostly reaching an area where it is becoming increasingly difficult. So I'm not sure. At least I won't suggest you to go into that area, and it is also very, very expensive. Can the links be given to Prasarvarti, Doordarshan, All India Radio, etc.? Which links? I'm not sure. Okay. Let me look at. I can see some questions. How we can differentiate between both of them? I don't know what it is. Masood Raza. I'm not sure. Like, what are the boths?
Okay, go to the next one. That the WhatsApp is end-to-end encryption.
How much? So in our mechanism is everything manual. So yeah, I mean, in this at this rate of information, you cannot simply afford to have a manual detect. Will hardly detect a few. Um, WhatsApp is an end-to-end encrypted. Is it possible for a WhatsApp bot to read data of WhatsApp? No, we're not doing that. What we are doing is that in your WhatsApp, we are telling you that it send it to our WhatsApp number. So there is one bot, you send it to that bot. So the bot has a premium account which has, so we can read from our own WhatsApp account, which is a premium account. Okay, and then process the data and generate the result. Can you apply fuzzy approach? I have used. I'm sure why not fuzzy, but fuzzification. I don't know how much data you will require and how do we fuzzify it. I'm not an expert in the area, but I cannot answer. But I have not seen great amount of utilization in that area. What is the name of the product? We have not named it yet. Okay, I am interested. Just a moment. More questions are coming. What is the response time to detect true news or fake news? In our case, it is, I mean, a few milliseconds. About, I mean, it is obviously with communication cost, it will be a few seconds because communication, I mean, WhatsApp communication is not that fast that it works in millisecond. But it's very few, like sometimes maybe 1 or less than 1 second. Okay. How can we track other WhatsApp number? We it comes from. Can we differentiate between state propaganda and fake news? If we identify the source, we know that whether it is a state or whether it is a commercial company or it is some kind of a publishing house. So how can we report if we identify some fake news in our system? Well, you are more than welcome, but we have not opened the system yet. Most likely, our target is around October. So if we do that, we will publicize and we will definitely send an email to CDEC as well. And I'm sure you will know. ISEA community will know once it is released. Yeah. So I think I have covered almost all questions.
Chat. Go to chat.
Okay, chat. A bit different. Can you please give me the current techniques of civil detection in OSN? Well, I do not have a ready mechanism of civil detection in OSN. I do not work in every possible areas. Whatever we more than welcome to send me an email and we can discuss on it. Right now, I do not have a mechanism. I do not know. Meta heuristic intelligent evolutionary search can you use? I'm sure you can use, but the result you'll have to see for yourself, like what you get out of it. Again, so evolutionary search and evolutionary meta heuristic and intelligence. I'm not sure. I'm not an expert on it. Fake news checking tools link you mean? Okay, so there are just Google on fake news checking. So BuzzFeed and there are many other websites available. But just Google it, like top 10 fact checking website. You will get it. How to check data from cybercrime databases? Cybercrime databases are not available for public. So if you are in law enforcement agency and if you have the right authorization, maybe you can. Otherwise, it is not a public data. Can you give number of WhatsApp bot? As I said, we have not opened it yet. Once we open it, we will give the number. Right now, it is still in beta testing phase. How can I identify newsware news document? I mean, it doesn't matter whether it is newsware or the print or whatever. The process is same. You can do the same. You can follow the same process. As I told you, you can go to a fact checking website and check. And if you want to build a machine learning algorithm, I discussed a few of them. If you search, like every NLP conference are publishing hundreds of papers. Okay, and then they are coming so fast that we are finding it difficult to cope up. So look at some of the famous one, the one which are very highly cited. Okay, and you will know where it is.
Okay. Can you hear me?
Yes, sir, I can hear you.
So one last question. Can we
Yes, sir.
recover deleted message in WhatsApp? After that, we'll conclude.
Sir, that will. The answer is a part of it is yes, part of it is no. If we have the device and if we have the right kind of um, technology, to some extent, yes. But in between, we cannot capture it because this is end-to-end encrypted and the encryption level is pretty high. But yeah, if we have an agent sitting on the, or rather, if we have access to the device, to some extent, not guaranteed, sir, to some extent, it is feasible. Sir, I will discuss this technique offline because it may not be
Okay,
right
no
to
problem. No
discuss
problem.
it. Yes.
That this is also you are doing related to the Assam police. Okay. I don't know.
Sir, I will neither confirm nor deny.
Okay, fine. So Ranbir, you have anything to add? Otherwise, we will conclude. Ranbir?
Yeah, I think almost all the questions seems to be covered. Yeah, I think that.
Okay. On behalf of participants and panelists, I heartily thanks to Firdous Ahmed Barmuya giving such a nice talk and giving some insight of fake news detections and techniques. Though it is use of machine learning, but it's very, very important for our coming up with a product. Thank you, Firdous.
Thank you, sir. Thank you for the opportunity. Thank you, everybody, for patient hearing.
Now we'll have a few minutes. Ranbir, you are the next presenter, correct?
Yeah, I think last opportunity.
So we'll 1 or 2 minutes, then we'll back, or you'll start immediately.
No problem. So one or 2 minute break we'll take and start.
And I don't think Ranbir require introduction because they don't want to. They last.
I think they are bored with my interaction.
Firdous, if
Yes, sir.
possible, Firdous, if you be there around for 10 or so, we'll
I
have
will.
some kind of panel discussions. Okay?
I will. I will be there, sir. Thank you, sir.
Okay.
Okay, sir.
We'll be back in 1 minute for next
Sure,
session.
sir. Sure, sir. Goodbye.
Ranbir sir, you can share your screen. Let's just keep first slide.
Ranbir, share your screen.
Okay, good. Thank you. Thank you.
It's working, so no problem. It's working, no problem. You can start talking. Ranbir, you can start talking. 1 minute is done.
Okay. So good morning to all. And once again, I think I'm going to my session. so the journey from the first day, let me just summarize. So we have briefly started with the introductions of different machine learning techniques and a few applications related to say hate speech detection, then fake news detection, and so on. But applications of machine learning as such in the social media analytics from the perspective of security is very large, right? It's a kind of ocean. various applications. So out of that, we are able to look at only few of them, and the idea for this is like say understanding of these basic techniques and realizing some of the few applications. So what I, instead of focusing on a particular area or domain, I was thinking that I will try to give some idea of other different applications where we can use this machine learning in the social media analytics. And these applications are required for, say, doing some of the, say, security related applications. So again, many researchers and students have done some, say, many projects in the OSINT lab. So I decided to pick up few of those relevant applications and say kind of discuss here, so that to give a kind of different views on different applications. So, but this I have selected only few, and for more details, you go to the lab website. You can also get other related areas. So to start with this, I would like to start with. Okay, that's why I have given the data mining at Ocean Lab, IIT Guwahati. Okay. So I'm starting with a very old study. So maybe my area happens to be in information retrieval, and I used to develop different search engine optimization techniques and so on. But as such, on social media data, I think this was my first work with Harshad Raut. He was the MTech student. So we started with a very simple problem. Then the problem was something like this. We used to receive many friend requests from different people, and many of them are not known to us. Many of them are stranger. Okay. Then we wanted to see how user react on the friendship request from stranger. That was the fundamental motivations. And at this particular time, Facebook, the restriction on the Facebook was not very high, so we were able to develop our own browser, say, utilities to create a kind of civil users and act like a kind of normal users. So for this work, what we have done was we have created about 40 civil users, 20 male, 20 female, and so on. And we have run this civil user for about a week, sending friendship requests to many unknown people. And we wanted to see how was the reaction. And we also, these civil users also get many friendship requests from others, and what is the characteristics of those friendship requests. So this is a brief statistics of that. So we have sent, say, from male civil users, we have sent to male users as well as female. Likewise, from female civil users, we have sent to male users as well as female users, and so on. Then we have devised for different strategy of attacking the user. Attacking in the sense that if I send a request to some unknown person, and if he or she accepts my request, I'm assuming that this is a successful attack. So the first category or first strategy is like we randomly pick up some users and send friendship requests. Then another is, second category is the suggest. Suggest is like Facebook will suggest users, right? So we pick up some users randomly from the suggested set of users by the Facebook. That is the second category. Another is, and third is the kind of group category. Group category are those users that belongs to the same category, like same school, same college, same hobby, and so on. Because we have created these civil users to look like actual users. So keeping a kind of very nice for the female users, keeping a very ideal photo like village girls or something like that of kind, then proper educations and so on. And the age range between something like 20 to 20. I forgot the actual age range, but like teenagers and so on. We have created just to look like a normal users. Okay, so each user joins some groups and so on. Then we also then pick up some users from the group and send them requests. Then the last is the kind of attack. So what we have seen is that from the first three category, when you send a user some request, if they do not accept, then what should we do to make him accept? Then what we do is, for those users, we have identified few set of users, few set of their friends. Suppose if I'm sending a request to you and you are not accepting my request, then what I do is I pull out your friend list and send request to your friend list. Okay, then again, after some of your friend will accept my request, after that, I will, after having some common friends, I will send friend requests back to you. Again, that is what we call as attack. Okay, so we have seen very interesting pattern here. So when you do this attack, even if say general pattern is like when a male send a friendship request, the acceptance request is not that high. Then male to female, it is lower than the male to male. Then again, female to male is very high. Female to female is low, and so on. So that basically means probability of a male accepting a friendship request coming from a female stranger is very high. At the same time, female to female seems to be a kind of reserve, and males seems to be open and so on. Then, if you look at the attack category, the number of acceptance, if you see the sending civil attack from the female, the number of acceptance is suddenly jump. So from a female users to a male, it becomes 29, so about 200 when it was, whereas it was something like 50 in the random. From the suggested, it is about less than 200. To the group, it is 170, and so on. Even if you see the female to female, so it is much higher, 163 numbers of acceptance, whereas other categories are less than 50. So this kind of pattern was interesting. So that this study, what we see is that many of the users are kind of vulnerable to stranger, even if they are not accepting in the first instance. There are many ways of winning your confidence and the kind of honey trap or something, kind of trapping you. Okay. So this is one simple study. So this is some graph to see acceptance rates between different genders and so on that I have already just briefly explained. So another thing, interesting part here is, so this is the number of friendship requests coming to us. So for the female users, we are getting many requests in this week. These are number of requests that we get in a week. But whereas to our male civil users, we are not getting any users. Any requests. That this is a very interesting pattern. So basically, what kind of information it gives? It also says that when if you are looking for a stranger, very likely that you are looking for kind of say female users and so on. So we did not probably get even a single request to the 20 male civil user time. So this was the kind of very my first activities in analyzing the social media data in OSINT lab. But this works to not be continued because of the various restrictions imposed by the Facebook from their side. Okay, so then we have moved on with the other social media data. So another interesting study that one of the another master student Mihir did with me in the year 2017 was, we are trying to see the political landscape of different political personalities using the Twitter data. So we also get very some interesting results out of this. So for doing this study, what we have done is we have identified 120 politicians from, I think, 6 political parties, and 3 of them in the kind of lefties, and 3 of them in the righties. Okay, so total 120 politicians, popular politicians. Okay, we have identified. Then we have also included few media houses, bureaucrats, and some random users who are following these users, 120 politicians, and this many number of tweets we have collected. Then we try to analyze this data. What is the pattern? So some of the interesting pattern is this network. If you see here, this network is a retweet network. When a person tweets one post, some other user again retweet that post, right? So this is the retweet network between the politicians. And the interesting pattern here is you can see that the people, this represent different political parties, but I forgot which what color corresponds to his political party. But I remember these bigger colors like pink and green. They are, one is Congress and another one is BJP, and others are allied parties. So from the retweet network, you can see that many of these users are from kind of a cluster. People belonging to same political party, they try to fall in say in a group. What does that? If a politician retweets some post, it is very likely that that tweet is coming from his peer members, very likely. So there is a very that and the practice of doing this is very high within the group than between the groups. So this this is one interesting pattern. So it says that, so if I have to, so this kind of network information is very important for many other application, even for say fake news, sentiment analysis, and this like then yesterday we talked about hate speech, and then likewise communal, non-communal, this kind of many of the say application, this network information is also useful. That is what I'm also going to show here. So next is like mention network. Even in the mention means if two people in a same tweet, if they co-mention together, they are connected. So if I have a kind of mention network, co-mention network, but here though they falls to in a cluster, but interconnection between the political party is very high, because you can see that from green to pink there are lots of connections, right? So that basically means even if people belonging to different political party, the chances of occurring in the network is in the tweet is high, and the mention network is a kind of noisy network as compared to retweet network. Next is like followers network. Again, you see that followers network form a very nice cluster. Pinks are together, greens are together, blues are together, blacks are together, and so on. Followers network is also a good network. So so this is the kind of network characteristic that we have seen, and we try to see how useful this network information in other application where we generally use only the text. So one of the application that we have done is something like ideology classification. So we want to identify whether a given tweet is whether a person is leftist or another is rightist or something that way. So one way of doing is, the first experiment that we have done is only by considering the set of tweets this user has posted in the past, only the content without the network information. Then these are the different classifiers, traditional classifier that you have seen in the previous discussion. And you can see this is the performance about 85% with the random forest and so on. Then on this content, we progressively add this network information, like say retweet network information, mention information, followers information, and so on. And as I said, that mention network seems to be quite noisy. So when I add mention network, performance even drop for the random forest. But and a similar pattern is also true for other classifier, except for linear SBM. I think linear SBM there is a slight improvement, which is very close. But in most of the cases, mention when you add the mention information, performance drop. That means mention network is a kind of introduce some noise to the original content. Whereas when you add the retweets and the followers, performance improves for many cases. Okay. So that is what we have seen from this one. So it says that these network informations are useful. Some additional information that can be used. So he further extend this work to earlier it was the ideology identification. Now he extend this to the sentiment analysis. So what he did was he collected about 5,000 tweets from this posted by these politicians about in the demonetization topic. So this data was collected at the time of demonetization. So we have considered demonetization as a topic and identify about 5,000 tweets from these politicians and manually tag them. Then we build the classifier. So when we build a classifier, so as you have already seen, one way of looking at is we have to do the feature engineering, right? So there are different ways of doing feature engineering. One is that the words present in the tweet itself, you consider as the features. Okay, that is when I do not have any expertise. But in the domain of sentiment analysis, there are various lexicon resources. Lexicon resources means some expert or group of researchers already identified few set of words belonging to positive sentiment or negative sentiment, new trend, and so on. Some lexicons are already built. So first 5 lexicons are standard lexicons that are freely available. So we have considered then some other features, information in the tweet, emoticon, part of speech, structural, say content like question mark, exclamatory mark, comma, period, and so on. Then unigram features that we discussed in the experiment. Then retweet features, mention features, following features, hashtag features, and so on we have added. Then you can see in the next slide, here also when you add the, say, so this is only using the lexicon, these are a performance. When you have on top of lexicon, if you have the tweet specific information like emoticon, part of speech, structural properties, and so on, again, performance improves. Then when we add the network characteristics, again, say it is going up to something like 94%. So it shows that network information also plays very important role in, say, solving such kind of problems. So I have just taken for sentiment analysis. The same will be applicable to other applications like head space, communal detection, because in a communal detection also, suppose some communal comment against something, right? So most likely, my friends also may have similar, say, view on that, or say my followers also may have similar view on that, right? So this network also gives lots of other associated information in addition to the content itself. Okay. And we have another interesting study, but I haven't included here. Even if I do not consider this content itself, without knowing the content, if I just randomly post something against someone, okay, or against some topic, what will be the sentiment, whether it is going to be negative or positive. So we have also found that only by exploring this association information without even looking at what I am posting, okay, we can determine say what may be the probable sentiment. Even if it may not be accuracy won't be that very high, but we will be able to get reasonable accuracy. That says that there is a strong bias by the association rather than the content. So many of the users in the social media, they are quite predictable. This is one interesting study. So okay, and so this study again we further extended to little broader. So what we did is using the demonetization, we have built the classifier. Then again, we have collected some more data from those people for the topics like GST, URI attack, Pathankot attack, and some more data set for the demonetization. And so using the classifier that we built from demonetization, we have built the classify this tweets, but we are not bothering about what is the class level, because what we want to do is not to check whether classification output is good or not, but we want to compare, say, similarity between different users based on the output given by our tool, one tool. So since we are using common tools, the output of the common tool will have similar characteristics. So even if you have misclassified for some tweets, it will misclassify for all similar tweets. So without worrying about the class level, we can use this information as the features. So that is the idea. Then when we do the correlation analysis, this is the interesting output. So this is the correlation between different users that we have considered. And you can see that these boxes are, I think, these are the different ideologies and the people belonging to that. So if you see some of the people within the ideology, they have quite disagreement with their peers. So I will show one thing. I think this particular green one, he is Navin Patnaik, I think CM of Odisha, and another person, high-profile person was Nitish Kumar, CM of Bihar. We have seen that they are their opinions are quite different from other opinions, their peers' opinion. And interestingly, we have found out this observation first, and I think after a few months after this observation, Navin Patnaik changed the political party or some party. That is a kind of, so it clearly shows that he is his opinions are quite different from his peer and so on. So this is one.
It is Ranveer, it is Nitish Kumar changed from
Sorry, I
Alliance change.
Yes. So
Alliance change of Nitish Kumar.
Yeah, I think Nitish Kumar changed. So we observed that few months before he actually did. Yeah. So that is the interesting observation. So with this, okay, this was about this political landscape analysis. Then, okay, this is for demonetization. Okay. So coming to, so we have, so extending this sentiment analysis problem. Okay, so Gyanendra, he was taking the first two lab sessions. He pick up this area as his research problems and started working deeper. So this particular work, it will be appearing in journals of intelligent information system. It is currently in preprint. So what he did here is, so if you look at the sentiment analysis literature, many of the earlier study will be on, it has a huge commercial value. But now slow, so all the resources people have created in the beginning are all related to customer review. But nowadays people are posting their view, people's view and comment in politics or issues, social issues in Facebook, Twitter, and so on, then many agencies need to analyze the sentiment pattern of the people, right, users. But we don't have much resources for the societal topics, but lots of resources for the product reviews and commercial topics. And that is the kind of the situation now. So what we did was, so there are many tools available publicly, and many agencies who are analyzing the people's sentiment on various social topics. They generally because they cannot, they do not have the resource to build their own classifier. So what they do is they use the existing tools. But sentiment analysis is a domain dependent. The system that you build from product review may not be effectively working for the societal topic, because these two texts has a diverse characteristics. But since people do not have option, they are using the existing tools. So we wanted to systematically analyze the response of these, say, off-the-shelf tools, and we have also built lots of inbuilt in-house classifier and try to analyze the weakness and the strength of different off-the-shelf tools and methods and so on. So this you can get from these journals. So this is the types of the different set of tools that we have built. So we have considered this above first tables, this 10 number of the self tools. This you can directly download and use it. This offline you have to download. This online you have to use the API to do that. Okay, and these are the methods used. In addition to that, we have built traditional this set of classifiers. Decision tree, k-nearest neighbor, SVM, linear logistic regression, and so on, adapters, and so on. These traditional classifiers. We also build these neural-based classifiers and try to see weakness and strength of this, all these, say, about around 20 tools. So this is the types of data set that we have used. So the societal 1 and societal 2 are the in-house data set created in the OSINT lab. Others are, say, SAM Eval 2013, 2016, Sentiment 140, IMDb, Amazon, Yelp. These are the standard data set available for sentiment analysis. So again, in the societal topic, we have subtopics like Kashmir unrest, Pathankot attack, surgical strike, GST, demonetization, URI attack, Paris Agreement, Syria crisis, and so on. So this data set we have used to evaluate the above tools. So what is the performance of this of the self tools? Okay. So if you look at here, among the, so when you apply these of the self tools on societal topics means the first table, above table. See, if you see the average, see, they are quite less. Many of them, except one, that is, I think, that is for the Paris attack. For all other category societal topics, the accuracy is very low. Whereas in the product review, so except for Sembel 16, which is again societal, Sembel 16 is societal. Except for this, for all other data sets, performance is relatively higher, and all other data sets are product review. Okay, so that basically means of the self classifiers, say the sentiment analysis tools are good for product review, but not suitable for societal topics. That is the observation. So, however, many of the studies, okay, lots of studies, many means lots of studies are using these tools to analyze the people's sentiment, whereas these tools are not suitable. Then, so just to summarize the table, we can show on the societal domain, all of these tools do not perform well, and some of the tools like Indigo, IO, Pattern, Emolex, and so on, CentiWordNet, even a single societal tweet was classified properly. So all are misclassified. This is what we observe. So likewise, again, in social media, quote mix is again another issue. So how robust are these tools on the quote mix? Because quote mix you cannot avoid. So the quote mix, what we have considered is English and Hindi. So here also you can see for the quote mix data, these tools are not suitable. But most of the social media comments are quote mix. So we cannot use, right? But still people are using because we don't have other tools. Then we have built in-house classifier and try to see other comparison. So when we build this classifiers on the societal one datasets and tested across other datasets. So like societal one test set, urea tech, and so on. If you see these are relatively higher than the previous one, and the first table is for the deep learning framework. Second lower table is for traditional classifier, and you can see the deep learning frameworks are superior than the traditional classifier. So the same classifier, now we have tested with the product review. So when you see the product review, with this is testing on the societal, and this is testing on the product review. So you can see that societal is much higher, so performance on the societal dataset is higher than the say product review. What does it, and on top of that, you can also see that if you test the classifier on the societal one itself, that means you are building on the same data set and the testing with the same data sets. So this is a homogeneous setup. So this is performance is higher, and the others data set are, though it is societal, they are under different topics. So this is the kind of cross-domain analysis. It says that sentiment analysis is the domain-dependent problem. At the same time, again, within the domain, you have subdomains, like within subdomains in the societal and the product review and so on. So societal cannot be used in the product review, or product review classifier built with the product review cannot be used for societal topics. So similarly, building classification or classifier on the product review, if you test on the societal, so this is very low performance, you can see here. But when you apply on the customer review, this is very high, right? So this also that is the cross-domain problem here. So after this, all this misclassified example, we have looked at one by one and see why are these examples misclassified. Then we have got so many interesting sub-issues that each of these issues are open problem in sentiment analysis itself. So one of the very challenging problem to handle in sentiment analysis of social media is something like sarcastic comment. So you are telling something positive, but actually you are insulting someone or say giving negative. So just one nice example we have here. Something Abdullah Omar, this is Omar Abdullah, and Zaha Sanjay, you must have had a grand pork party on Uri and Pathankot. What does it mean? It was a comment at the time of Uri attack and the Pathankot attack. So basically, so if you look at this tweets, it's everything is positive. The content of the tweet is positive, but actually the meaning is kind of say this person is insulting Sanjay, right? So likewise, above again, there are many such interesting sarcastic comment. Content will be positive, but actually it is negative. This is very difficult to handle. Then aspect based. Aspect based means in the tweet itself, you may have some parameter, something like if you look at the mobile review comment, something like the mobile is very nice, but battery life is poor, something like that, then the battery life is an aspect, and the user is telling that overall average review is good, but battery is bad. So this battery is called aspect, and the battery is bad is the say sentiment of the person against the battery. So that those are the aspect based. Likewise, code mix, noisy text, like say short form, long form, creative writing. Then observer biasness, because something which is negative will be positive to other guy, which is nothing called as a stance detection. Then neutral sentiment. So this is again very interesting example. Okay, it is he's writing to Barkha. Okay, Barkha Burhan Wani is your headmaster's son. So if you look at this, there is no sentiment. This is a kind of neutral text, but as such, he is insulting Barkhadat, right? So these are the kind. So these are the kind of challenges that is very difficult to address without doing specific feature engineering tasks. So this type of analyze, after finding this error, then we try to check this existing tool, what are the strength and weakness across different classes of the tweets, like if, how they perform in the reporting tweets, aspect-based tweet, stance tweet, sarcastic tweet, quote mix tweet, and so on. So though the performance is poor, on an average, CNN-based deep learning framework seems to be performing better than the other framework. And none of these existing tools, except 52% in the reporting, okay, and some 60 here, majority of them are less than 20 and around 20 for the say off the shelf tools. Okay, so that clearly shows that they are not developed to handle social media data. So this is to summarize. So for the reporting, for the reporting, neural base is for except for stance and the code mix, neural base seems to be superior than the feature base and the other tools. But this comparison between the neural and the feature base is subject to correction, in the sense that we have tested with some set of data sets. So the pattern might be different for other data sets. And the feature selection that we have done is the very generic feature selection. We have not done specialized feature selection. But if you come up with some expert-based specialized feature selection, domain-specific feature selection, performance for the feature selection-based classifier should be improved. So since we don't do feature selection for neural, so we have just used the traditional feature selections in the feature-based classifier. So from this, what we have seen is that from this study, from this we have seen that say these tools are not suitable for social media data. Then how do we add? So there are many possible ways. There may be many possible ways of looking at. So one way of looking at is using the meta information like hashtags, user profile, mentions, and so on. Okay. So in this particular study, so this study was published in IEEE Transaction on Computational Social System. So here, this is again contribution from Gyanendra. So here we have looked at, yesterday we have seen how to create embedding for the words, right? So here we have looked at how to create embedding for the hashtags. Why? The reason is if we are able to create embedding for the hashtags, we can check whether say in the way we are using for NLP framework, we can check whether, say, hashtags are useful or not. So we have created something called sentiment hashtag embedding, where every hashtag that we get, just like a tweet or words, we are trying to assign some sentiment level, positive, negative, or neutral, and so on. So, here we have used various framework. So some of the framework that we have used is some word embedding. Word embedding is skipgram and Shibo that you have seen in the yesterday's lab. So we just created, we have included the hashtag in the text and created the embedding using the skipgram and Shibo, and look at the hashtag itself. Other types of embeddings, which we call as a network embedding. Okay, there are. I just briefly explain what is network embedding. So these are the different network embedding that we have also used and try to use this embedding to create, say, sentiment embedding for the hashtags. Okay, what embedding you have seen yesterday? What is node embedding? So forget about the node embedding or what embedding for some time. Okay. So let us see that the underlying data that you are having is a network. Okay? So when you have a text, I know how to apply these machine learning tools. When you have a network, how do you apply a machine learning tools? Right? So there are different ways of doing it. So network embedding is one such idea for representing the network so that vector-based machine learning method can be directly applied for any underlying problem like network clustering, network classification, network, say, substructure mining, then link prediction, community detection, and so on. Many applications. So if I have the representation, existing space-based machine learning method can be directly applied. That is what the network embedding. So just to briefly illustrate what is network embedding. So I have a network in the left-hand side. My task is to represent this network in a vector space. So in this example, my vector dimension is 2 x axis and y axis. So network embedding can be done at different level. The first one is the node embedding. Node embedding means every node in the network will be represented by a vector. Likewise, edge embedding, every edge can be represented by a vector. Substructure embedding means subgraph of the network, subnetwork, they are represented by a vector. Likewise, entire network can be represented by a vector, and so on. You can have at the different 4 levels. And the node embedding, what I just mentioned here, is nothing but every node in the network will be represented by a vector. So this deep work, node to back burst, multi-view embedding, hashtag to back, and so on, they are the state-of-the-art node embedding methods. So now, how do we generate this network embedding? Okay, so just to summarize, in the word embedding, we try to find a similarity between the words. Just like that, network embedding also, we try to find a similarity between the nodes. So this is the proposed model. So I am not explaining the mathematical details because I just wanted to make it non-technical. So you have seen transfer learning yesterday. Okay. So this is another task of framework in machine learning, something called multitasking framework. So multitask framework. So we have used multitasking framework for this proposed model. So in the multitasking, what the idea is, instead of solving one problem, let us solve multiple problems and try to learn the common features. That is the idea. So the framework, so if you see here in the left-hand side, the input side, you have one incoming pipe, and it is branched out to one upper branches and a lower branches. So what it does is, so just to briefly explain, so given a hashtags here, okay, I have some neural models here. This is CNN-based models. I have neural models here and try to generate the same input that I have given. If I give something like one hashtag like say COVID-19, I am looking at to produce COVID-19. So upper branch. So when I try to reach COVID-19 to COVID-19, I will learn the internal representations. Okay, and this internal representation, I will branch out to another classifier, whether this representation is positive or negative. Let us say COVID-19 is negative. Okay, let us just assume. Then I will build this classifier and say whether it is giving negative or not. Suppose if it is not giving negative, that means my representation is not correct for the sentiment. So I need to do some correction. So this will again do the feed forward backward propagation and correct this as a representation. So this is what the C is. So after doing training this for lots of hashtags, we get this representation for every node in the network. So this has very interesting. Okay, before that, this is the brief data sets. This is the network characteristics, and this is the set of lexicon, small size that was used for say building this bottom branch. Okay, so once you after this, let us see what is this one. Okay, so MBE is a multi-view embedding. This is just one embedding with say one state of the art embedding among many that we have used. I'm just trying to show you. Suppose if I give Facebook as the say query query hashtags, and the others are the set of hashtags that are kind of say written by these methods. Okay, so when you see Facebook, these are Twitter, June 90 speech, these are the kind of result that you're getting. Whereas when you put say C on multi-view embedding, so you are getting like Facebook, LinkedIn, Google, then online shopping, like something like that. Okay. Likewise, delete Facebook. This is one propaganda for Donald Trump. You can see Donald Trump and so on. President Donald Trump. These are the set of this one. So when you put try to visualize them in the two-dimensional space, you can clearly see that delete Facebook and the President Donald Trump's comes quite closer in the C space. Similarly, you have many examples. Similarly, here also you can see Thailand rescue, Kerala flood, and so on. So the keywords are, so the dots that you see in the multi-view, they are quite scattered, whereas in the multi-view with C, they are quite dense. They are very close. That means what? All of them are, these terms are very close to each other. So likewise, so we are able to get better representation with the C. Then just to look at the performance, again, you can also see that with the C, you get much higher performance than the say without C. Okay. Then when you apply this the tweet embedding that you get from the C, when you apply for the sentiment classification, you can see that this dark bar is for the C, and the white one is the traditional classifier. So you can see that there is a significant improvement in the performance. Okay. And the many interesting results. So one of the results that I have not put here is that we using this, we are able to mine what are the trolling hashtag for some personalities. Just take examples like our Prime Minister Modi, what are the trolling hashtags? For the Rahul Gandhi, what are the trolling hashtags? So we are able to find very interesting trolling hashtag people use to troll them. That is also one application here. Another application that I want to mention here is, as you said that, as we know that say social media is noisy and it is multilingual. So by doing so, we can also find the hashtags in other languages, sentiment of those hashtags in other languages. So few example is like So we have seen some EBM hashtags in Hindi, some in Tamil, and I do not. And below you can see some in Thai, some in Korea, Japan, and so on. Okay. So these are the list. So these are the hashtags, negative and positive hashtags that we found from this analysis. And I do not know what are these meaning. So we have given this to Google Translator and try to see verify them whether they are positive or not. Okay. So this red color is assigned using the Google Translator. So we have manually check and look at the person. So this is very, so using this, we can even extend to sentiment analysis of other language. Okay. And there are studies that sometimes a hashtag, emoticon, these are enough to say what is the underlying sentiment in many of the applications. Okay, so they have very, they provide very rich information to identify the underlying sentiment without looking at the other keywords. Okay. They are not enough, but they also provide good information. Okay, so another work which is under review, maybe expecting to get positive results very soon. So this is again, so in the previous work, we have seen the use of, say, hashtags. So now, hashtag is one side. Another is the noisy text embedded in the tweet, because of which you are not able to get the proper classification. Okay, how to rectify that noisiness? That is what, so in this work, Gyanendra and Anasu, another research scholar, they collaborated and solved this problem. So in this problem, they use the concept of something called multi-layer network, okay, multiplex network or multi-layer network. So what we do is, so if we have a tweet which is noisy in the noisy and underspecified. Noisy means it might be in different language. In the English tweet, you may have some Hindi words, or say if your the tweet is very short, so they are underspecified, you don't have enough information to classify, then what we do? So given the tweet, we try to find what are the important terms in these tweets and select those important terms and supplement those under important terms with the other, say, useful information. That is the idea. Suppose if I say COVID-19 is a hashtag, my tweet is having COVID-19, then other hashtags like SARS, coronavirus, these are again important hashtags related to COVID-19, right? So if I'm not able to classify only with the COVID-19, then if when I supplement them with SARS and the coronavirus and so on, you will be having much richer information. That is the idea. Then where do you get this, supplementary information? That is where we use something called multi-layer network. Multi-layer network, nothing but you have a layers of networks. Each layer, so in this example, one layer is the keywords, another layer is hashtags, another layer is mention, and if they co-occur together, they are connected and so on. We have created this multi-layer network. From this multi-layer network, we have created those embeddings that we have embedding, and some we have also proposed our own embedding methods, and using those embedding methods, we are able to find good supplementary information. Then we have added those information to the tweets and build the classifier. That is the framework. So here, this is the brief, this one. Original tweet, the first row is the performance. Then these are the proposed methods incremental in incremental manner. And these are the different sub-modules for creating the embedding. But technical part, please go to, yeah, you please need to go to the, so that part I'm skipping, I'm just providing the idea. So this, so using this, these are supplementary methods, data you're providing. So when you provide a supplementary data, you can see that performance are improved. Okay, I think my time is almost over, but let me try to end. So here, so this is one way of handling the issues. Okay, so these frameworks are very generic. It doesn't matter what is underlying language. Right, that is the again advantage of these frameworks, because in my C framework also I don't worry about the language, right? I just need the structure. Likewise, in this also, since I'm getting the supplementary material from the structural property, it doesn't matter. It is a generic framework. It does so it should work with other languages as well. So this is another interesting work. Let me try to quickly mention this. So we have seen that people are posting many opinion in the Twitter, right, against certain topics. Say COVID-19, many people are commenting it. So now we wanted to understand the emotion inherently present in the tweets. Is it changing? Okay. So suppose you have terrorist attack, you have commented with a very sad emotion, then you keep on participating in the posting, and will your emotion be changing? If it changes, why it is being changed? What influenced you to change? Okay, that is what we wanted to analyze. So this work was done by Devasis Naskar. He is the PhD scholar in University of Valencia. So he did this work when he did internship in the lab, and so it was published in ASEAN Transaction Information System. So I will just briefly explain the idea. So this is the data sets. We have selected about 12 different topics, and this is the data set that we have collected. And what we did is this data we have processed in something like this, transform into something. For a given user, he is first posting a tweet, participating discussion in one topic. Okay, then this T2 is the second post from this user, and in between many other peoples are discussing. Okay, so we wanted to see sentiment in the first tweet and the sentiment, not sentiment, emotion in the first tweet and emotion in the second tweet are the same. If they are same, that means there is no change in emotion. If they are different, then there is a change in emotion. Okay. If it is change, what causes this change? So in order to understand that, these are incoming. Incoming are like say people are replying to your comments, or people are making some comment using the same hashtag that you have created, or people have written something using your username and so on, mention and so on. These are incoming tweets that he will be receiving. So this tweet he can see, looking at those tweets, is he changing his emotion? That is what we wanted to see. Okay. So how do you assign emotion? Okay, we have used a pretty simple and standard models for that. We have something called Russell model for affection. It creates lots of affection given affections. Like say left hand side is the proposed affection from the Russell, and we have, instead of having this lots of these 16 say affections, we have just clubbed them into 4: R1, R2, R3, R4, and so on. R low negative, low positive, high negative, and so on. From activation to pleasant, deactivation, unpleasant, and so on. Okay. So we have every tweet that we receive, we have assigned this for one of these 4 classes, and check that is what the emotion is. So once we do this, we look at some transition. I'm skipping all other parts of main part I'm presenting. So this diagram, this transition diagram is for every topic that we have considered. What is the transition of changing emotion? Okay. So what is the probability of changing from R1 to R1 to R2, or say residing in the R1 itself? Okay, so this is the transition you can see for this one. And the transition in the left hand side is the kind of summary of all these topics. You can clearly see here that R1, which is high positive, if you are in the high positive, the probability of retaining in the high positive is very high, other changing to others. But whereas if you are in R4, which is high negative, probability of changing to high positive is higher than positive probability of staying. Similarly, from R3, probability of moving to positive is high. From R2, probability of staying back to the R2 is high, and so on. This is the summary of this. So it says that with large probability staying R1 is high, but there is a transition. people change, right? Why it is being changed? What caused these changes? And is this different for different categories and so on? If it is the attack security related, is the pattern different? If it is something like movie Bahubali or Alien Convent, is the pattern different? Like that is what we were trying to analyze. But another this interesting what we can see is, so this map try to summarize this transition. You can see that there are lots of users without any transition, but there are users with the transitions. So with the two transition is less than one, and you can interesting you can see that there are people with up to 12 transition, lots of transition happenings, right? So that there are users with some kind of, so this person might be kind of random person, or say maybe a robot person also, not sure, but you can see that there are, though it is limited, there are people with very high transition. They are not, they can be probably easily influenced. So the user who will never change, there is no way that you can influence them, right? If you want to influence somebody, that has to be someone who will be changing their mind. So this transition analysis for the users will also say whether he can be influenced or he cannot be influenced, that kind of study. So just some findings, some brief findings. So does the incoming message influence user? So we have seen that significant number of posts do not agree with the dominant emotion. Dominant emotion means dominant incoming emotion, and his emotion, user emotion. We have seen that there are many significant number do not agree. That means people do not tend to change. It's not that one change, but lots of people do not change their stand. So if I want to influence somebody, so our assumption that social media can influence people, right? So, but there are lots of people who that you cannot influence. That is what the finding. Another is like if users change, what is causing? So which channel is more influenced? Suppose if I want to influence someone, so people from the same member list is like in the same group, people from the followers and any random persons. So if I want to change somebody, then I should be under which category? I be the in the same group members? Should I be one of his followers or any arbitrary persons? Okay. So we have found that member list has the higher potential of influencing people. If I people comment from the members have higher probability of influencing others. So that basically means if I want to influence someone, then I have to win his trust, right, by joining his community or some close circle and so on. That is important. Another is among the communication channels like retweet, hashtag, reply, mention, which is more influential. From this study, we have found that retweet is having higher influence than the others. This is sentiment and the tweets part. Similarly, and one of the and again in sentiment, social media problem is everything is mixed, right, and noisy. You need to identify first thing for many of the NLP is that you need to identify what is the underlying language, right? So this Nilakshi, yeah, she will also be taking today's afternoon sessions. These are some of the contributions from her side on the language identifications. These are two of the selected publications from her in this line, but more other publication you can see from the lab website. Okay? So here we have taken something like Assam as the case study, where because Assam is a kind of is a area where you can find people speaking many languages. Okay, so here we are having people like speaking Assamese, Bengali, Hindi. So we have collected data set from a very close multilingual conversation data, and from there we try to analyze the user's characteristic and see say how identify, and all these posts are noisy posts. Then we try to identify the language. So for more technical details, please read these papers. I think because of the time, I will probably skip this with brief say discussion here. So language identification can be at a sentence level, word level, subword level, say multi-grain level. Subword is again interesting. You see, if you see class, if in the class, if you add E, this become class A. It's like Bengali. So class become Bengali words, something like that. So in the first, so your language need to be identified in the say sentence level, in the word level, in the subword level, and so on. So she work in the sentence level and the word levels. So I think I'll skip. So, but one interesting observation here is in this from this data. So in the x-axis of the for the first row of the figure, x-axis shows the number of messages, and the y-axis shows the average number of languages present in that. Okay. So you can see that in a message, there are some messages up to something like 4 languages. This is very interesting, right? So likewise, and again in the bottom row, if you see, uh, axis shows that is it users with a unilingual, bilingual, trilingual, and the more than tri. So though majority of the users are unilingual, that basically means he posts only in the one languages. So there are significant number of users posting in the multiple languages. It's a bigram, trigram, and more than 3 languages also. There are people posting more than 3 languages in the same conversation. That is the kind of interesting pattern. So idea here is that because of the noise present in the text, identifying language in the word level and the user level, sentence level is challenging. Okay, but by using the user's information, user affinity towards the language, can you say improve the performance? So this study shows that users' language affinity information can improve the language classification performance. I will. This is the proposed model. I will skip this, and from here, another interest. This is the task. Another interesting thing is, okay, from this we can improve up to something like we can achieve up to 96% or 93%, 96 on the Twitter and 93 on the YouTube datasets. It's a very huge improvement in the baseline. But on top of that, one more thing I want to share is this characteristics. So here, what I have shown is how many words are shared across the languages. Suppose TSE da in English will be te in Hindi, right, or in Assamese, right? SE, he in English will be he in some other language. So likewise, there is a lots of vocabulary share vocabulary across the languages, and they have their own legitimate meaning. So that makes the whether TSE the occurs in a sentence, whether it is going to be English the or the in Assamese. That is the kind of challenge. Okay, so but again the percentage of sharing such word is extremely high in across languages. Okay, so these are the challenges. So apart, I think apart from this, other activities that we do in the lab is like text regularization. That means in the noisy text in the tweets, can we correct it using these machine learning models and so on. So I think this is the last slide, and I hope some of the application related to social media analysis using machine learning technique, I'm able to convey. Thank you very much.
Thank you, Ranbir. I think you have not mentioned one of the main activities that text data analytics we did it, somehow missed it. Also some other.
Apart from that, we have this network analysis, then terrorist attack prediction, and so on. Those things, I think, I could not
Also
cover.
text data analytics. We did it project.
Yeah,
So
yeah, yeah.
that we have forgot.
Multimodals, right?
Multimodal
Uh-huh.
for security concern.
Yes, yes, yes.
Okay, anyone have any questions? Few questions was there in chat box. If you can see.
Let me open this. Okay. What is the difference between sentiment analysis and big data analysis for real world practice? Okay. big data analysis is a kind of framework or scenario where you are assuming that you have a big data and you want to analyze, you need to find some hidden pattern in that. So when you have a say big data, what are the challenges? One challenge is the computational resources that care. One should be scalable. Scalability should be taken care. Likewise, so big data is a kind of generic framework where you assume that you have a huge amounts of data, and this data can be relational, which is structure. This can be unstructured. Okay. So relational and unstructured will have their own challenges, but big data as such, it says that you have huge data, and you have to perform some tasks within some in a very effective manner. So whereas in sentiment analysis is just one class of machine learning problem, classification problem, where given a sentence or words or document, you want to say whether this document or sentence is carrying positive sentiment or negative sentiment and so on. Next question is, what is smart embedded network? Oh, I think this is different from network embedding. I think embedded network will be. I'm not very sure, sir. Can you answer this?
Well, I think question is going on. I'm not able to see the question. It is private question most probably.
Question is like, what is smart embedded network?
Smart embedded network. I think smart embedded network, nothing to do with the data, social media generation, machine learning. We do only the network embedding. Smart embedded network, I have not heard about it. I cannot give.
Embedded network and network embedding, I think these two are going to be
Two different.
Yeah. I can guess what can be the embedded, but I think it's for us in academic, better researchers should not probably guess. So I will not guess it. Okay, so
Better not to comment. Better not to comment.
Yeah.
So in chat, one question is that what would you say be the most important checkpoint to keep in mind while using ML techniques when implementing sentiment analysis of tweets for detecting hate?
Okay, so if you look at sentiment analysis, hate speech detection, then communal or non-communal detections, emotion detections, they are all, if you talk about a framework, I believe they are all same because the model as such that we propose in the sentiment, it is applicable in the emotion also, hate also. But where the problem is, these are some specialized problem in specialized problem in itself where you have a distinct characteristics. So feature engineering, finding the appropriate model is one side. Even if you have the model which is applicable in all these domain, you need to know those appropriate features. Okay, so my belief is identifying the domain specific challenges, issues is the key. When you talk about sentiment analysis in a traditional text, that is okay. But when you talk about sarcastic, quote mix, then noisy text, stance, and so on, they are sub-specialized problem within the problem. Within the sentiment, these are the open sub-specialized problem where general framework will fail. So we have to identify those characteristics and features that will solve this problem. Or say you have to bring in the resources or features from other meta information or external resources to address this. So similarly for other as well.
Okay. So sentiment analysis in case of cyberbullying, that is the question. How can we use sentiment analysis cyberbullying? And another question is similar, is that abusing online trolling and cyberbullying are same topic. These two are related questions.
Again, I can solve part of cyberbullying using sentiment analysis, where sentiment can be considered as a part of as one possible features, but sentiment alone may not be sufficient, because cyberbullying, it may be emotion associated with that, and it may be stance associated with that. It may be then the group of people that belongs to. For example, say, let us just take example with Congress and BJP, right? So message coming from Congress to BJP, the same message, it may carry different meaning. So likewise, there are many parameters. That's what I was telling, like this understanding the characteristics or nature of the features and nature of the information that you need is the key. So in the cyberbully also, sentiment analysis can be used as one of the features, okay, but this alone may not be sufficient.
Correct. Oh, one more questions which you cannot answer, but I am reading. What kind of analysis we can do in? I think I can answer. Our power system. Let me answer this question. Is basically power grid analysis, power grid communications, and power trading. Specifically, power trading is working in power trading, which buy and sale of power in different time and consumption of power, everything. If a person has knowledge of power system, they can easily find out there are several meters pluses in across the power systems, starting from the generation to transmission line at 10, 15 minutes interval or certain interval, the information reach to one place, and that information, that is SCADA, and SCADA is also used and power trading is also used. There are several algorithms used for analyzing to buy, if I go for power trading, when to purchase power and when to sell power and when to stop the hydropower generation, when to run the hydropower generations. This is one kind. Another kind is how load shedding can be managed, how where I can get more and when I can guess. All kind of machine learning techniques using power sensor data and analyze using machine learning. So it's a different kind of machine learning for analyzing the like big data analytics. Hope I able to give. If those are interested, you can contact to the us. Will try to do it. The last question is trolling and phishing relation. You have any in Ranbir?
Trolling and
Phishing. Phishing. These
sir,
two are two different things. Different things. Trolling, you can say. Phishing is totally different. Phishing is getting the credential of different meaning. Means. So these two are two different things. I don't know why the person has written trolling and phishing as a relation. These two are two different things. Well, by trolling, we can, if someone is responding some of the questions or some of the query in the trolling, it may lead to phishing also, but they are two different. They are not related. I think any more questions you have, Ranbir? Otherwise, you can close this for the from the audience. From the attendees and panelists, I thanks Ranbir to give the nice informations related to social media analytics. Hope we will get similar thing in future. Thank you.
Thank you, sir.
So next, what is our plan next? Second half, we can just inform and we can close.
Sir, we will have lab session from 2:30 here. Yesterday we have started very basic neural network, that is the perceptron, multi-layer perceptron. So we will discuss about RNN and LSTM, CNN models, and some neural models for doing NER or part of space that Ashish discussed for the traditional one. So we also give information for the neural base. So these three models, Nilakshi will discuss with examples. And after that, we'll have a brief panel discussions.
That will be around
Around
4:10.
No,
4:10?
it is going uh, 4:30 or something.
No,
But I
4:15
think
we will start.
uh,
We'll
all
see.
the panel member may not be able to attend, but who can make it, we'll discuss with them.
Yes, there will be some quiz after 2-3 days. Some questions is from some participants. There will be a quiz after few days for certificate.
Okay. So, sir, regarding sharing of the resources,
Yes.
so currently, since our lab members are not in the campus, there are some issues. So I am planning to put up all the resources together in the our lab website by tomorrow. So I think this quiz can be little delayed by some days if.
Agreed. Agreed. Quiz will be organized by our CDAC Hyderabad, and they will take care of it. Naresh,
Okay.
you can say. Naresh, you can say. Naresh, are you there?
Might have gone for lunch, so we'll take the lunch break now.
Okay. So quiz will be organized by ISEA PMU, and they will come up with information to. Hmm. Fine, no problem.
Sure, sir.
We'll
Thank
we'll keep our all resources in the our
you.
link. Okay. Fine. Bye for the time being. We'll come back around 2:25. We'll start. Bye.
Nilakshi?
Hello?
Yeah, I'm just. Can you check a slide?
Okay. Yeah, one second, please. Okay, one second. So my screen is visible, right?
Yes, yes, you can see your screen.
Okay.
So we will wait for some time. Maybe 2:35 will start.
Okay, sir, sure.
Nilakshi, shall we start?
Yes, I'll just take 2 minutes to start.
No problem. No problem. So you start now.
Yeah, I think we are good to start. It's 2:36.
So once again, very good afternoon to all the participants. So this is the last session of this 1 week, 5 days program. So today, Ms. Nilakshi Sharma will be continuing the yesterday's lab sessions. Today she will covering different neural network models and few of the examples using those models. Nilakshi, please.
Yeah, sure. Thank you. So yeah. So yesterday we had seen some simple neural networks where we have basically seen some examples of feed-forward neural networks with fully connected layers. And so today we'll continue with that and we'll try to see into some of the popularly used different neural network architectures. Going into too much details of those may not be possible within this session, but I'll try to give an overall idea so that interested people can further explore these architectures. So yeah, so some of those contents have been borrowed from some of the blogs that have provided some very new, nice illustrations and some lectures from CS231 and course. So all the examples of neural networks that we have seen yesterday are basically feed-forward neural networks. Why we say that they are feed-forward neural networks? Because inputs are all fed in one direction. They move from the input layer to the hidden layer, through the hidden layer to the output layer. So there are no connections within the same layers or from or any backward connections. All connections are in the forward direction. So we also call all these networks feed-forward neural networks. For example, in this example shown in the slide, we have a neural network with 2 hidden layers, and all connections are from the input layer towards the output layer. There are no connections within the same layer. So we have seen that when we have a neural network, there are basically 2 stages in which the training takes place. One is the forward pass. In the forward pass, what we do is that we feed the input, the weights and biases are randomly initialized, and the transformations are applied, and we obtain some output. Then based on the loss that we obtain, we try to tune the parameters, that is the weights and the biases, and while tuning the parameters we move from the outer output layer towards the towards the input layer. So basically all the neural networks, it consists of a forward pass and a backward pass, or a forward propagation and a backward propagation. And so just to mention here that forward and backward propagation will take place in any neural network, irrespective of whether they are feed-forward neural networks or recurrent neural networks. These are the basic steps that all the neural networks follow forward propagation and backward propagation to learn the weights and biases. Now, all the network examples that we have seen so far are composed of fully connected layers. What do I mean when I say fully connected layers? Fully connected layers means each node in one layer is connected to all nodes in the following layer. For example, if you look at this diagram here, each node in the input layer is connected to all nodes in the hidden layer. Similarly, all nodes in the first hidden layer are connected to all nodes in the second hidden layer, and so on. So that's why we call this type of layers as fully connected layers. Now, the disadvantage of this fully connected layers is that so basically, what are these connections? These connections are nothing but this comprises of the parameters, that is the weights. So the more connections we have more parameters. That means we have to do more number of computations, which is very expensive. Also, the question is that do we require this many number of connections? Is it required that all the nodes in the input layer should be connected to all nodes in the hidden layer? For example, suppose we have been trying to see some examples like sentiment classification, so on. So while we try to determine the sentiment of a word, is it important to take into consideration the information about all the words, or if we take into consideration the information about only the surrounding words? For example, one words in the left and one words in the right. Are those kind of information sufficient to capture? So we will see that. So basically, in all the the idea in different neural networks is that can we optimize on the number of connections so that we have less number of parameters and we require to do lesser computations. Also, if we have more number of parameters, there are more chances to overfit. So the lesser parameters are always better. So one attempt or one model that explores these characteristics, that is to minimize the number of connections, is the convolutional neural networks. So what the idea behind convolutional neural networks is, can we replace this dense fully connected layers by some sparse local connections? What do I mean by sparse local connections? Means that can the nodes be connected locally? For example, the nodes in the input layer are connected to some only few neighboring nodes in the hidden layer, and so on. So that will reduce the number of connections. So a convolution. So this is what a convolution neural network does. It tries to reduce the number of connections by replacing the dense connections by some sparse local connections. So in a convolution neural network, we have three are basically composed of three different layers. One is the convolution layer, another is the pooling layer, and finally we have the fully connected layer, which means that the last layer of a convolution convolutional neural network will always be a fully connected layer. That means the output nodes in the output layer will be connected to all the nodes in the hidden layer just before the output layer. But in the other layers, we'll try to reduce the number of connections. So let us see what how each of this layer functions: the convolution layer, the pooling layer, and the fully connected layer. So the name convolution layer basically comes from the name convolution. So convolution is nothing but we can visualize it as a matrix operation. So basically you have a large matrix, and which is basically our input, and you have a smaller matrix which we call as filter. What we do is that we try to slide this filter over the input and perform certain operations. Basically, we perform the dot product operations. For example, suppose if you look at the example here, this green matrix here represents the input, and this yellow matrix represents the filter. Basically, what we are doing is that we are sliding the filter over the input matrix and performing the dot operations. So what do we actually achieve by this? So this will be clear if we try to visualize this in the form of in the same representation that we have been exploring so far, in the graphical representation. So if we look at the figure in the right, these are the kind of neural network architectures that we have seen so far. We have seen that the input layer and all the nodes in the input layer are connected to all nodes in the hidden layer. In the convolution layer, what we basically do is that we replace these connections by some sparse connections that you can see in this figure in the left. So for example, suppose we have this matrix, this input matrix, and we have a filter of size 2 by 2. Okay, so this filter, values in the filter matrix are the parameters that we try to learn while training a convolution neural network. So if we see, for example, when we apply this filter over these first 4 values of the matrix, we perform element-wise dot operation, and that product is stored in this node A1. Similarly, with the same set of parameters are applied over the next elements in the matrix, and the value is stored in this node in the hidden layer. So there are 2 points to be noted here. One is that we have replaced all the dense connections, and we have very sparse connections between the input layer and the hidden layer, and the weights are also shared. For example, if we see all the weights, this nodes in the hidden layer A1, A2, A3, A4, they share the same weights. So basically the idea is that we try to reduce the number of parameters by reducing the number of connections, as well as by sharing parameters between different nodes. Right? So what we have in convolution layer is that we have sparse connections, which means that we have less number of parameters, which means that we have to do less computations. Also, we share parameters, so that when we have shared parameters, again, this means that we have lesser number of parameters, which means we have lesser computations. So computation in a convolution neural network is substantially reduced as compared to a fully connected network. So, okay, sorry. So after the convolution layer, what we have is the pooling layer. So one point that I'd like to mention here is that, so here we have shown an example where we are applying one filter over the input. For example, here we are applying one filter over the input. But in practice, we generally apply multiple filters over the same input. And so the idea is that, for example, one filter will, so basically the idea of using filters is that each of these filters will try to capture some characteristics via the parameter values. So when we have multiple filters, means that means that each of these filters will try to capture multiple features or different features. So after the convolution layer, what we have next is the pooling layer. So pooling layer is applied after the convolution layer, and it even further reduces the size of the representation. For example, if we look at this matrix here, the first 4 elements correspond to the output of one convolution operation, that is applying one filter over the entire matrix. Suppose we have applied 4 filters, and we have this corresponding to each filter, we have 4 different values. So after that, what we do is that max pooling operation. What we do in the max pooling operation? Max pooling operation is, again, we consider a window size. For example, we can consider window size of 1, 2, or according to our requirement, we'll tune the window size. But basically, the idea is that we apply a max operation over the fixed window size. For example, here if we consider a window size of 2, then if we consider a window size of 2 by 2, then we consider this first 4 elements in the input matrix, and we select the maximum value from this portion of the window. Similarly, we'll apply the same window size over different parts of the matrix and apply the extract the maximum value. So basically, the idea behind max pooling is that the most important feature in feature from the input will perhaps be represented by the highest value in the convolution layer. So by max pooling, what we are trying to do is that we are trying to extract the most important features from the convolution layer. There are other pooling operations, like instead of max pooling, people have also tried to do mean pooling. So instead of extracting the maximum value, in mean pooling we'll be extracting the minimum value, or you can do average pooling where we'll be considering the average of all the values. So these are different different ways in which these operations can be explored, and we can see the effect of this. So once we have the convolution layer and the pooling layer, we can have, so here we have shown example of one convolution layer and one pooling layer. So we can have multiple convolution layers stacked one over the other. We can similarly have multiple pooling layers, and at the end we will have one fully connected output layer. So for example, here after the convolution layer, we'll have one pooling layer that we have not shown in the figure, but at the end we'll have an output layer that will be fully connected to the layer just before it. So in a convolution network, only the output layer is fully connected, and all other layers are sparsely connected. So what we have seen is that the point to be taken from the convolutional neural networks is that they allow sparse connections and they allow parameter sharing, and basically the idea is to capture the local information by using small number of parameters. Now, but the thing is that for some applications, capturing the local information might be sufficient. For example, if you're trying to determine the sentiment of a word, you will probably look at two words before the target word, two words after the target word, and that information will probably be sufficient for you to say whether a particular word is a positive sentiment word or a negative sentiment word, for example. But there are some cases in which we do require information about larger sequences. For example, suppose let us consider this example. I visit India every year and I fall in love with this place over and over again. So, consider, for example, you're doing some co-reference resolution where you basically try to relate the pronouns with the respected nouns. So if we look here at the sentence, the word "this" is actually referring to India, which occurred at the very beginning of the sentence. So in order to be able to capture this information that this word "this" refers to the word India that perhaps occurred in the beginning, two or three words within the beginning, two or three words of the sentence, we need to we need to maintain the information about the entire sequence. If we maintain only the local information, in that case, we perhaps will not be able to capture this information that the word "this" is referring to India. So for such type of applications, convolutional neural network may not be very suitable if we use very small window sizes or small filter sizes. Although convolutional neural networks have also been used but we cannot say but they may or may not give significant performance because they mostly capture the local information. So to capture this long-term information, we have something called the recurrent neural networks. So recurrent neural networks are basically used when successive inputs are not independent. For example, if we look at the sentence, if we process each word in the sentence independent of the previous words, then probably we will lose the information about this word "this" referring to India. So whenever we need to maintain information about the subsequent or the previous words in the sequence, we use recurrent neural networks. For example, some common examples where recurrent neural networks are used are, for example, part of speech tagging, where in part of speech tagging, what we basically do is that we try to find the part of speech corresponding to each word in the input. For example, suppose given the word "I live in India," to determine the part of speech of the word life, you perhaps need the information after words occurring before the word target word and after the word target word. Why? For example, I live in India and I am watching the match live. So in the first place, in the part of speech of life of live in the first sentence, and the part of speech of the word live in the second sentence will be different, and this difference will be able to capture only if we maintain the sequential information. So RNNs have been found to be very useful for such kind of sequence labeling problems where we need to maintain the information about the entire sequence. Typical examples, like I said, part of speech tagging, NER tagging, pronoun resolution are some examples where this kind of networks have been found to be very useful. Now the question is that how are recurrent, what is the or how are the layers in the recurrent neural networks organized? That's they are so much useful in capturing this sequential information. So basically, so to understand the difference between a feed-forward neural network and a recurrent neural network, let us try to look at these examples. So in a feed-forward network, what we do is that we have the input, which is passed to the hidden layer, and then which is passed to the output layer. So there is no relation between the subsequent inputs. For example, if I have, I process the first word in the sentence, then I process the second word in the sentence. There is no information that is when I'm processing the second word, or the second input, we are not maintaining any information about the first input. But in recurrent neural network, we maintain that information. How do we maintain that information? We maintain that information via a self loop. What do I mean by that? For example, if if you look at the if you look at this diagram in the left, we see that the hidden layer is receiving input only from the input. The hidden layer has only input that comes from the input layer. But in a recurrent neural network, a hidden layer has two inputs. One that comes from the input layer, and another that comes from the hidden layer itself. So to visualize this properly, we can visualize this in this form. So what do I mean when I say that the hidden layer receives input from the input layer as well as from the hidden layer itself? Which means that when we process for example, I have a sequence of words x1, x2, x3. When I pass x1 to the network, we have some information that we have stored in the hidden layer, and then we have passed on the output of the hidden layer to the output layer. Next, when I fit the next word in the sequence x2, I also maintain the information from my previous input. So the information about the previous input is stored in this hidden layer, and when I'm considering the next input, I'm in addition also considering the input from the previous hidden layer. But one thing which should not be confused here is that this U, W, and V matrices are not different matrices for different time stamps. We only have one U matrix, one V matrix, and one W matrix that is being modified throughout the entire sequence. This illustration on the right is just to show like how the information is stored when we are processing our sequence. But these matrices are basically, we have only three matrices: input matrix, a hidden matrix, and an output matrix. Then the same matrices are being iterated when we process the input. So there can be different type of recurrent neural networks based on our application. For example, we can have a recurrent neural network one-to-one, meaning that we only have one input and we have only one output. Next, we can have one-to-many. One-to-many means we will have only one input node, but perhaps we'll have many output nodes. For example, typical example could be like, for example, when you're trying to generate a caption, given an image, we are trying to generate a caption. So basically, your input is one node, but your output is multiple nodes. Then many-to-one. Many-to-ones means you have a you have multiple input nodes, right? Means we have a sequence of length more than one, but we want to extract only one output at the end of the sequence. For example, when you're trying to classify the sentiment of a sentence, you probably if the objective is to find the sentiment of the entire sentence, we would probably want to extract the sentiment at the end of the sentence. So basically what we'll do, we'll have multiple input nodes, we'll have multiple tokens as inputs, and at the end of the sentence we'll have one output node. So basically this this means that at the end, when we have processed only the entire sequence, the hidden state at the end actually captures the information about the entire sequence, and from the hidden state at the last timestamp, we get the required output. Next, we can have many-to-many, which means that we can have many input nodes as well as many output nodes. So many-to-many can again be two cases. For example, consider the case of part-of-speech tagging, or consider the case of NER tagging. So in part-of-speech tagging, you will need to know the you will have a part of speech corresponding to each word. So that means that for each token, you will have okay, I'll try to answer these questions afterwards. So where was I? Okay, so for example, in cases like part of speech or named entity recognition, you will have one output corresponding to each timestamp or corresponding to each token. So in those kind of problems, the number of output nodes and the number of input nodes will always be equal. That is one example of many-to-many. For example, part of speech tagging or name entity recognition, and so on. Next, we can also have cases where we have multiple input nodes and we have multiple output nodes, but the number of input and output nodes may be different. For example, consider the problem of machine translation, where the input is a sequence. We have multiple tokens as input, and the output is also a sequence. We'll have multiple tokens as output, but the number of input and the output nodes may not be equal. For example, when you translate a sentence from English to Hindi or from Hindi to English, the number of words may change. So those kind of so how we basically so the idea behind those kind of models is that you process the entire input sequence, store the information about the input sequence in the hidden layer, such that the hidden layer corresponding to the last input timestamp contains the information about the entire sequence. Then, starting from that last timestamp, we can then start generating the output sequence. So these are different forms of recurrent neural networks that we can have. We can have one output corresponding to multiple input tokens. We can have one-to-one correspondence between the input and the output tokens, and we can also have many-to-many correspondence, where we may not have one-to-one correspondence, but multiple input nodes mapping to multiple hidden nodes. Sorry, multiple output nodes. So these are the different types of neural networks that we can have. Okay. So similar to other networks like that we have seen in case of feed-forward networks, where we have backward propagation, in neural networks also we'll have backward propagation. I'll not go into the details of this because going into the details of this at this point may become a little clumsy, probably we don't have much time. But a little difference from the case of the feed-forward neural networks is that in the feed-forward networks, we do not maintain the sequential information, but here we maintain the sequential information, right? So when we are when we are propagating the errors, we not only propagate it through the layers. For example, we had seen an example yesterday where the errors were propagated from the output layer to the hidden layer, and from the hidden layer to the input layer. But in case of recurrent neural networks, back propagation will be in two directions. One is through the layers, that is from the input layer to the hidden layer to the output layer, and second is through the timestamps. For example, from the last timestamp to the previous timestamp, continuing back to the first timestamp. That's why backpropagation in recurrent neural networks are also called as backpropagation through time, because we backpropagate not only through different layers but also through different timestamps. So we will not get into the details of this backpropagation now, but one idea here that is important is that when we are backpropagating through different from the output timestamp towards the input timestamps, we involve in repeated matrix multiplication. Now, what are we get involved in the multiplicative forms of the weight matrix many times, which is if the sequence is the longer the sequence, the more number of multiplications we'll have. Now, what is the implication of that? The implication is that when we have very small values in the weight matrix, for example, and when you are repeatedly multiplying these small numbers, your result tends to get smaller and smaller and smaller. So what happens is that as you proceed from the hidden layer to the from the last timestamp towards the first timestamp, your gradients become so small that the parameters in the initial timestamps may not change at all. So initially we randomly initialize the parameters, and if the parameters do not change at all, that will affect the training. It will affect the training means your weights will not be tuned properly as per your requirement. So this problem is known as the vanishing gradient problem, which means that as you proceed from the last timestamp towards the initial timestamp, your gradients continues to grow smaller and smaller, and it will almost have no effect on the parameters of the initial timestamps, which will affect the performance of your model. So these are the limitations of recurrent neural networks. Okay, so in the backward pass, we have already seen what is the limitation. The limitation is that the gradients diminishes through time, and the parameters at the initial timestamps may not at all get changed. Also, it is not only about the gradients diminishing and the parameters not changing, but we have some limitations in the forward pass as well. What happens is that, for example, consider that we have a very long sentence. What we are basically doing, what we are basically doing is that we are overwriting the information in the hidden node. As we proceed from the initial timestamp towards the end, the information in the hidden node is being overwritten time and again till we process the entire sequence. Which means that if we have very long sequences, as we reach towards the end of the sequence, we may lose the information of the beginning words in the sequence. So that is another limitation of recurrent neural networks. One is that if we have very long sequences, then the information that is being captured in the hidden state may not capture the information of the initial tokens at all. And secondly, during the backward propagation, the parameters during the initial timestamps may not be changed or may not be tuned at all. So to come up with this, to address these limitations, different architectures or different modifications to INN have been proposed. For example, one modification that have been proposed is called the LSTM, or we call it the long short-term memory networks, and the other Other variation is the GRU, that is the gated recurrent units. So I will not get into details of this, but to give an overall idea what these variations, for example, LSTM or GRU tries to do is that instead of overwriting the entire input, the input actually passes through certain gates. These gates are nothing but sigmoid or 10H activation functions that determines how much of the input should be added to the current state, or how much of the input from the previous time step should be added to the current time step, and so on. Basically, the idea is to manage the flow of information both in the forward direction as well as the backward direction, so that we do not have these problems, the problem of diminishing information as well as the problem of diminishing variance. So basically, if we try to look at the difference between RNN and LSTM, this is what. So in the RNN, we have the input, and we have the input. We have the current input, and we have the input from the previous timestamp or previous hidden state that is being added to the current hidden state. In LSTM, instead of adding the input directly, the inputs are first processed through different gates that determine how much of this information should be captured, and how much of this information can be eliminated, and then only the hidden state is updated. So what the LSTM does in the forward pass is that the gates control the amount of information to be written to the current state, and so that no unnecessary information is added to the current state. Similarly, in the backward pass, the instead of repeated matrix multiplications, we have element-wise multiplications with the gate that solves the problem of vanishing variance. So all the examples of this recurrent neural networks that we have seen so far are unidirectional. Unidirectional meaning that the information only flows in one direction. But sometimes it may also be helpful if we have the information about the next timestamps. So for such cases, we have bidirectional recurrent neural networks. So what we have in bidirectional recurrent neural networks is that we have multiple hidden layers that capture the information in different directions. These hidden layers might be a simple RNN block, or it might be a LSTM block or a GRU block. So as we can see in this example here, we have the input. The first layer is processing the input in the forward direction, and the second layer is processing the input in the backward direction. After that, the input from the forward direction and the input from the backward direction are combined. This combination may be in the form of concatenation, averaging, or some other operations, on top of which some activation is applied, and we finally have the hidden layer. So for some applications like machine translation, or even named entity recognition, where we have ambiguous words, having the information about both the in both the forward and the backward direction may be helpful. So that is what we can try to capture in bidirectional recurrent models. That is, we capture the information in the forward direction as well as the information in the backward direction. So with that, I think I've tried to give an overview of the different architectures, and we'd like to see some implementations, how we can use these different neural networks, like convolutional neural networks, LSTMs, or RNNs, using the available libraries. So, sir, should we proceed towards the codes?
Yeah. So just one information. We will have a panel discussion at 4:15. So we'll have we'll have only up to 4:15, not 4:30.
Okay. Yeah, that's, I think it's 3:15 now, so we have 1 hour. It should be okay. Okay, so I think the code has already been shared, and I hope everyone have downloaded the downloaded the codes.
Gyanendra, can you share the GitHub link again?
Yes, sir. Yes, I'm sharing now.
It just take some time to authenticate my. Should we start, or should we wait for some time for the people to download the code?
Yes, let us just check if they are able to open the GitHub and download the code.
Okay.
Dear participant, can you please confirm if you are able to download the file?
Yeah, when you're downloading the code, there is an additional dataset that has been uploaded. So kindly download the new dataset as well. That's the previous datasets are the same, and we have additionally added one more file.
Yeah, I think some of them are able to download. Yeah, Nitakshi, many of them have confirmed, so I think
Okay.
slowly start.
Okay, sure. So we are again using the same sentiment analysis data set for today's session as well. So I'll not go through the pre-processing modules. We have already covered them yesterday, and I think most of you are comfortable with that. So basically, loading the data set, cleaning the data set, and then shuffling the data set so that dividing it into training set and test set, and then we are assigning unique IDs to each word in the vocabulary, and we are generating the training set and the test set in this format. So the training set is a list of tokens, and that and so that in the training input we have a list of tokens and the list of class labels corresponding to each sentence. Similarly, we have the test set built in the same manner that we have built yesterday. So yesterday we had used used two simple fully connected layers to classify the data set. Today, let us try to use CNN. So they are not like in terms of implementation. There you won't see too many changes. We'll have to import these layers, that is the convolution layer and the max pooling layer, and you can also import the LSTM layer and the bidirectional LSTM layer. That will see how you have used them in the subsequent this thing. So yeah, another thing is that if you remember from yesterday's session, yesterday we had used a sequential model. What is a sequential model? Is basically it allows the layers to be stacked one over the another in a linear fashion. So we can also we also have another type of model, and which is defined in the model class. Basically, in the model class enables us to do is that you can have you can have multiple connections. For example, you can have multiple input nodes, you can have multiple output nodes. So when we have this modern one connection between subsequent layers, we can use the model class instead of the sequential class. So today we will try to, even though all the codes that we are going to going to see today, we can also implement the same using the sequential class. But for the exercise today, we'll be using the model class. Okay, so the first input layer where we define the shape of the input. So our input are sequences, and each sequence is of size max length. So that is what you specify in the input layer. After the input layer, you can add one embedding layer. So what this embedding layer will take as input is that it will take the number of words as input and the embedding size as input. What is an embedding? What is the dimension of the embedding that you want to generate? And based upon your provided parameters, it will randomly initialize the embeddings for all the words. So you have an input layer, and now this input layer is added to the embedding layer. So basically, these inputs are randomly initialized by the embeddings. So on top of that, now you will add a convolution layer. This is conv 1D. So that is we'll do 1D convolution. Generally, we do 1D convolution, and 2D and 3D convolution are more used in images. So this is the layer for 1D convolution, conv 1D. The first parameter here is the number of filters. So as I said that we can use multiple filters. So here we are using number of filters, each of size 3. Okay, so we have 128 filters, each of size 3. We have padded all the sequences so that all the input sequences. Then we also need to specify the activation function. Yeah, so yesterday we had seen sigmoid and 10H activation functions. Today we'll see the ReLU activation function. And strides equals to 1. Strides means that when we are applying the filter over the input, what is the difference? What should be the difference between the subsequent sliding? Should we continue to slide continuously, or should we slide keeping some fields in the middle. So it is so we have the input randomly initialized by the embedding layer. On top of the embedding layer, we are applying a convolution layer with 128 filters, each of size 3. Then after the convolution layer, we are adding the max pooling layer. Then on top of the max pooling layer, we are adding a fully connected layer that is given by this dense layer, and the size of the and at the output layer we are having 2 nodes because we have 2 classes, and we are using softmax activation function because it will give us the probability distribution across each of these classes. So here we have defined the model that this should be my model. This is my input shape. Then we have an embedding layer, a convolution layer, a pooling layer, and an output layer. Once I have defined all the models, now I call the model class. And while calling the model class, I provide as arguments the input, that this is my input layer, and this is my output layer. So the model class will take this input layer and the output layer as the arguments, and this model class will be initialized. Once this is initialized, we will next need to compile the model. So here, while compiling, we have seen yesterday that we need to specify the loss function. We also need to specify the optimizer. Yesterday we have used the stochastic gradient optimizer. There is another optimizer called the Adam optimizer, right? And then what are the metrics that we want to see while training the model? So here we specify the metrics as accuracy. So the model has been defined, the model has been combined. So finally, we said we fit our train our model. So for training, we have the fit function where we provide the input, we provide the output, and we mention the batch size, and we mention the number of epochs. Okay, so we can train the okay. So those who have downloaded can try training the model, and okay. So we are so in each epoch we see the loss and the accuracy corresponding to each epoch. So once we have trained the model, we can evaluate the model, right? So when we evaluate the model, it gives us output, the loss, and the accuracy over the test set. So this is the loss over the test set. This is the accuracy over the test set. And again, like we have seen yesterday, so these are the overall loss and the overall accuracy. If you want to see the output corresponding to each test input, then we can use the predict function, right? So the predict function will take the test input, test set as input, predict the levels, and then it will basically return a list, each element in the list corresponding to the predicted level for each input sentence. So we can visualize this. We have the sentence, we have the actual class level, and we have the predicted probabilities. So this is the probability corresponding to the first class, and this is the probability corresponding to the second class. Okay, so I hope it is clear till now. So here what we have done is that we have initialized the embedding layer randomly. We have specified that this is the size, so this should be the size of my embedding. This is the size of the vocabulary cross the embedding size, and the embeddings are randomly initialized. Instead of that, we can also use pre-trained embeddings, right? So yesterday we have trained and trained the embedding model using the word2vec model, and we have saved the embeddings in the words and the vectors file, if you remember. So what we can do is that instead of randomly initialize the embeddings, we will now load these embeddings and initialize the embedding layer with this pre-trained embeddings instead of randomly initializing. So what we basically do is that we have we read the words and the vectors, and we load them into a dictionary. So this embeddings is a dictionary where the key is the word, and the value is the vector representation of the corresponding word. So once we have this dictionary, we can use this as input to our embedding layer, but the embedding layer requires a matrix as an input. So what we will do, we will convert this embeddings from dictionary into a matrix. So you should be careful when generating this embedding matrix, because each row in the embedding matrix should correspond to the corresponding word ID. For example, the first row of the embedding matrix, it is the 0th row of the embedding matrix, should be the embedding corresponding to the word with word ID 0. Because when we are feeding the input to the model, we are basically feeding the word IDs. And this embedding layer will use the word IDs and this embedding matrix to initialize the inputs. So you should take care that the word IDs and your rows in the embedding matrix have one-to-one correspondence. So that's what we have tried to do here. For each word in the embedding, we are checking the word ID and we are appending the if we have a corresponding word in the embeddings dictionary, then we are loading it into an embedding matrix. Otherwise, we are just keeping the embedding values as 0. So instead of keeping this as 0, so you can also randomly initialize following some distribution. There are different ways in which you can try initializing. So this is the embedding matrix that you have loaded. So now the model definition, the remaining part of the model definition will remain the same. Only difference will be in the embedding layer. So in the embedding layer, we have defined the size of the embedding matrix. This should be by size of the embedding matrix, vocabulary calls embedding size, and initialize the weights of the embedding matrix by my pre-trained weights. So my pre-trained weights I have saved in the embeddings matrix in a matrix form, and I'm using this as my input in the embedding layer. So instead of randomly initializing, all my words will now be initialized using the pre-trained embeddings that I have loaded in this matrix. Then the remaining things will remain same. We have the convolution layer, we have the max pudding layer, we have the fully connected layer. Then we initialize the model, we compile the model with the required loss functions and optimizers, and we finally train the model. So you can see the losses, accuracies for each epoch. So once you have trained, you can again, as like we have done in the previous cases, evaluate the model and see the loss and the accuracy corresponding to the test set. I hope everything is good so far. Now, instead of using an RNN, instead of using CNN, we'll now try to use RNN. Now, what form of RNN this will be? This will be a many-to-one RNN, because we have a sequence of multiple tokens, and we will predict the output only at the end, because we only want the output corresponding to the entire sentence. We want the sentiment level corresponding to the entire sentence. So this is a many-to-one RNN. So similarly, first you have to define the input layer, define the shape of the input layer. Next, you define the embedding layer. Here also, I have used the embedding pre-trained embeddings. Next, I call the RNN layer. So simple RNN is the vanilla RNN that we have discussed. So other RNNs are like LSTMs, and other variations are like LSTMs and GRUs that also we will try to use. So this right now you're using this simple RNN. This first value here is the number of nodes in the RNN block, and this is the activation function. So we'll use 10H activation, and the RNN layer is composed of, that is the input layer, hidden layer is composed of 64 nodes. And then on top of the hidden layer, we add an output layer composing of 2 nodes, right? So far we have defined the model. Again, like in the previous cases, we initialize the model with the input layer and the output layer. We compile the model, and finally we train the model. So once you have trained the model, we can again evaluate the model, and we can see the loss and the accuracies. Okay. Similarly, instead of using simple RNN, we can use LSTM. Again, all things will remain same. We'll have the input layer, we have the embedding layer. Depending on whether you want to use pre-trained embeddings or not, you can set this parameter matrix here. After that, we now replace the simple RNN layer with a LSTM layer. So this we already have this built-in layers. We'll simply import them, use them, determine the number of nodes, the activation function, And then on top of that, we again add a dense layer with 2 nodes. Then this is then we initialize, compile, and train. So all these models so far, the RNN and the LSTM models that we have seen so far are unidirectional LSTMs or unidirectional models. We can also use bidirectional model. What we have to do for that, we'll simply use the bidirectional module. So we already have a bidirectional module that takes another layer as input. So what kind of bidirectional layer do we want? We want a bidirectional LSTM layer. So that's what we have specified here, bidirectional. This we want a bidirectional LSTM layer. Each layer will be consisting of 64 nodes and we'll be using the 10H activation function. Right? So here we'll have, so when we do, we have basically added 2 LSTM layers, one in the forward direction and one in the backward direction. Then on top of that, we have this output layer, it is a dense layer. Then again, like in previous cases, initial train and then evaluate, right? So far what we have seen is that we have seen many 2-1 models where we have a sequence of tokens, one output corresponding to an entire sequence of tokens. We are determining the sentiment at the sentence level. Instead of that, there might be cases where we want many to many RNNs in the form that we want one output corresponding to each input. For example, in case of part of speech tagging, or in case of NER tagging, or even in case of sentiment analysis, we might want to predict a sentiment corresponding to each word. We'll try to see an example for that. So right now the dataset that I have added is a language identification dataset where we have the language level corresponding to each word. Okay, there are different datasets that are also publicly available for part of speech tagging and NER tagging. You can download those datasets and try to use them. We'll see how to, so I'll basically show how to build a sequential tagging model, and then you can experiment with the different datasets. So if we look at those who have not looked at the input file, if you take a look at the input file, input file format, I have the word / the level word. So previously what we had is that we had entire sentences and the label corresponding to each sentence. Now instead of that, I have the label corresponding to each word. So these are basically the different classes corresponding to each of these words. So what I'll do here is that first I will load this data set, then I will split it into training and test. Before shuffle it, I forgot to include that step here. So what you can do is that you can before generating the train set and the test set, you can randomly shuffle your data set. Okay. So right now I have considered a very small data set of 100 lines for illustration. You can download other data sets and look into bigger sized data sets as well. So now I have shuffled the data set and divided it into train set and test set in the 80-20 train set and test set. Now next what we have to do, like in other models, we have to assign ID corresponding to each word in the vocabulary and corresponding to each level. So previously we have seen that in these examples, actually hard-coded the number of classes, which in practice is not a very good idea. We should not hard-code this. So here you see how to unique IDs to the classes and use that in your program to generate the training set and the test set. So what I've done so far, I have shuffled, I have divided into train and test sets. Now I load all the words in the dataset and all the classes or all the labels that I have in the dataset. So I'm reading the reading the file line by line. Okay. Then for each token, because my dataset is in this format slash the class level. So for each token, what I'm doing, I'm splitting it on slash. Then the 0th part of the word will when I split it, I have a list of 2 elements. The first element is the word, and the second element is the class level. So I iterate through the entire data set so that I have the list of entire vocabulary, as well as I have the list of entire classes, as well as I have maintained the maximum length that I have in my data set so that all input sequences are padded to the same length. So I just try to see some details. So we have 1032 words in the, we have 6 classes, and our maximum sentence length is 80. So what I've done here is that I've set the maximum length to 10 so that I have small size data set for now illustration. But in practice, you can remove this and see the results of the larger data set. Right now, if I have 80 line sequences, the data set will become very large. So I have just set the max length to 10. So once I have loaded all the vocabulary and all the classes, next I need to assign each a unique ID to each word. So that's what I do here. I have created a dictionary for mapping each word text, and I also have a reverse dictionary that have the index and the word information in case I need to map the index to the actual word in future. And to handle any unseen words, I use a special index, that is index 0. Good so far. So here we have assigned unique IDs to each word. Similarly, we can also assign unique IDs to each classes, right? So we create a dictionary to map the classes to the corresponding index. So this is my dictionary of classes where the value is the class level name. For example, this is my class level name, and I'm mapping that with unique integer. Okay. And I'm also maintaining a reverse index in case I need to map the index to the actual class in future. So we have 6 classes in our dictionary. Okay, so you can also see the classes. What are the classes that I have? For example, if you try to print the dictionary. So these are the class levels that I have, and I have assigned a unique ID corresponding to each class. Okay, so now I have the unique ID for each vocabulary. I have the unique ID for each class. Now I need to prepare my training and the test set using these unique IDs. So my training set will be prepared in the same manner that I have done in the earlier cases. So basically what I do is that I read files line by line. Okay, then I extract the words and the labels corresponding to each word. I have truncated in case the sentence length is more than the max length, I have truncated it to the max length. You can ignore this. And then I have assigned, I have mapped the words to the corresponding IDs that I have created using the word to ID dictionary. Now, similarly, I have to map the labels. Now, in our previous cases, what we have seen is that we have one label corresponding to the entire sentence. But in this case, we will have one label corresponding to each word. So here, that is what we'll do. So in my labels, I have the information about the labels of all the words in the sentence. Now, I am converting of this words, each of these labels to the corresponding one vectors. Okay, so first I create a vector of size number of classes, then the index corresponding to the required class is 1 and all other indexes are 0, and then I am appending that to my vector. And in case I have sentences of length less than the max length, then I am simply padding all the words with zero IDs, and all the labels as well with list of zeros. So if I try to see this, so we can see the class labels, how the class labels here are. Right. So now for each sentence, I have a sequence of class labels. For example, in my sentence of length 10, then I will have 10 one-hot vectors corresponding to the class level of each word in the sentence. Right. Then similarly, I'll prepare the test data in the same manner where the X factor, it is the input is corresponds to a list of IDs, and the output is a list of one-hot vectors. So this is my, for example, this is my input, and this is my output vector corresponding to this input vector. So now I have multiple values in the level vector as well. And once I have prepared the input and the output in training in a test data set in this manner, next I have to define my model. So I am I'm importing the required layers. So this LSTM layer we have already seen, embedding layer we have already seen, dense layer we have already seen, time distributed layer we have not seen. So whenever you are doing sequence tagging, we have to import this time distributed layer. Okay. Next, you define the input, which is the maximum length of the sentence in your data set. Then you initialize a embedding layer. Then, so here you can use the pre-trained embedding. Since I do not have the pre-trained embeddings for this data set, I am randomly initializing here. Then I add a bidirectional LSTM layer. So if you check the difference between the bidirectional LSTM layer that we are using here, and the bidirectional LSTM layer that we have used in the previous class of sentence classification, we will see that we have one difference, that is this return sequences. So what this return sequences, so now what we have to do, we have defined the LSTM layer. Okay, and we now also need the output corresponding to each input token. So what this return sequences gives us is that it gives us an output, the output corresponding to the hidden layer at each timestamp. So basically here with these return sequences, I have the hidden vectors corresponding to each timestamp, and now I will add a dense layer on top of the hidden layer at each timestamp. So for that, we are using this time distributed layer. So these are the two things that you have to keep in mind when you are building a sequence tagging model. One is in the bidirectional LSTM layer, you have to use return sequences so that it returns the sequence of the input vectors, and then use this time distributed layer. What it will basically do is that it will add a fully connected layer to the hidden layer at each timestamp. Otherwise, the hidden layer is added to only to the last timestamp. But here, since we want the output at each input, we'll add the output layer. We'll add the output layer to the hidden layer of each timestamp. So these are the two differences that you need to do when we are doing a sequence tagging. So once we have done this, then again you initialize the model, you compile the model, and then you run the model. So once you have, so this will generally takes a little more time than other models, because here you are finding the output at each input. Then you can similarly evaluate the model over the test data. Okay, I have to run this again. Okay, so this gives me the loss in the accuracy corresponding to the test data. Now, if I want to see the output corresponding to each each input, that also I can check using the predict function like we have seen earlier. So now if I, so this predict function returns a list of predicted labels for each input sentence. Now for each input sentence, I have multiple predicted labels because I'm predicting the output at each timestamp, and my output is the size of number of classes. Since I have 6 classes, I have each vector of size 6, and this different values indicates the probability for the class level corresponding to that index. So here, so similarly, for if you want to do an name entity recognition or part of speech tagging, this is how you have to define your model using the LSTM. The return sequence is set to true and using the time distributed layer. Then you can also experiment the same thing with other available data sets. I think that's all we have for now. So we have some time, so if there are questions, I think we can take some questions.
Yeah, thank you, Nilak. Yeah, let us take questions. So there was some question from some participant. Let me. Okay, one of the question is, what is the relation between hidden layer and output layer? Can you briefly answer that?
How do I answer that? So this hidden. So what the hidden layer relation between hidden layer and output layer is what? So the output layer will take the state of the hidden layer as input, perform the apply the transformation, and then finally we have the output. So I don't know, like that is the relation. How can I answer that in some other way?
Yeah, that's fine.
Yeah.
So other question I could not see. If you see other question, you can.
Yeah, that is what is the relation between hidden and output layer. I think this the relation between hidden and output layer is same for all networks. If you are confused about this.
Okay, one question is there a limit on number of hidden layers we can have?
As such, there is no limit on the number of hidden layers we have, but the problem is that the more number of hidden layers we have, then again we'll have the problem of this vanishing gradients, because we have multiple computations across different layers, and when we have multiple computations, if your values are very small, then repeatedly multiplying small values will diminish the gradients, so that may affect the performance of your model. So there are different so if you are using many number of hidden layers, so there are different things that you need to take care of. For example, you can add residual layers, or you can perform normalization of the values at each hidden layer, so that this kind of problem of vanishing gradients do not occur.
Okay, just to supplement to what Nilakshi just said, now she defined different neural models. So what we call as the deep neural model. Okay, deep neural model is nothing but having multiple layers between the input and the output. So if you're considering a multi-layer perceptron, having layer will make your multi-layer perceptron deep, right? Similarly, in the LSTM, you can have multiple layers of LSTM. So, okay, so that is how you can have a deep model. But when you add on the multiple, so when you do the back propagation, you have to propagate your error backwards. Okay, so there you if you do not take care of the back propagating factors with appropriate activation functions, then you may have still banishing gradient or exploding the gradient. Okay, so that has to be taken care. Then another question is why the accuracy in training a sequential tagging model is near 0.31 or so less. Yeah, Nilakshi, can you see that?
Yes, I'm not able to see the question, but yes, the accuracy is less because right now I have considered a very small data set of only 80 sentences, and we have around 6 classes in those 80 sentences, and the embedding are also randomly initialized. So one is if we have one is, and we have also trained for only less number of epochs, right? So we can try training for more number of epochs. We can try increasing the training data because using so less data, the parameters will not be tuned properly. So for tuning the parameters properly, you need a larger data set. So if you train over a larger data set, and if you train for more number of epochs, your accuracy will improve.
Next question is what should be the parameter when we start to solve our problem using a neural network, like when we use CNN, RNN, LSTM? What I am not very sure about this question. What should be the parameter when we want to solve our problem using neural network? Okay, so CNN, RNN, LSTM are all different neural network models. Okay, so can you elaborate your question once? So next question is, if the training size is any use of using batch size?
So if the training size is less, is there any? Well, it all depends. So how less is your training data? If your entire training data can be loaded into memory at once, yes, you can avoid using the batch size. So generally use batch size because of multiple reasons. One is because of memory requirements. Second is because of time requirements as well.
Another input to the participant is when you use neural models like deep neural models, you need to have huge data set because we are not trying to use the explicit features since you are trying to learn the features by its own. So you need to have a huge amounts of data. Okay. I think there are more questions. What can be various methods if sample data is too small? Sample data should be large in neural network. Okay, so but
Yeah.
if you are using deep neural network, you have a reasonable data set size. Otherwise, we have to work on the feature engineering. You using the defined feature, still you can build a neural model, that is fine. But if you are not defining the say explicit features, data sets. Okay. Another question: how much processing time it takes for a sentiment analysis for a state prior to electron? What I the questions?
Election system.
Oh, election. Okay, sorry, it is election. This is also not the question is not clear. Okay, Anamika has elaborated the questions. I want to elaborate the question again. Please consider this. Like for the head speech detection, what architecture I should choose? Whether to try with all and decide the one with the best accuracy, or some other parameter. This is a bit difficult to see. As we mentioned in the morning also, head space, sentiment, these are all specialized problems that need to like understand the nature of the data set and the possible features. Okay, so is one aspect, feature is another aspect. So if you have a good features, even the say these general models may work. If not, then you have to figure out where say what kind of model you need to design. Okay, so this is yeah, you have to look at the state of the art literature. Okay. One another interesting question is there a way to generate synthetic data based on real data so that boost the dataset size? So Nilakshi, the question is, if you are having limited data, okay, how can you boost the dataset? Can you build the synthetic datasets or other methods of? So to answer,
Yeah. So actually, yes.
yeah, continue, Larsen.
No, actually, I don't have a specific answer to this question. What I wanted to say was that yes, there have been some studies that have tried to generate synthetic data for different problems in the text domain. But yes, while generating those synthetic data sets, you have to be aware of the nature of the actual data set so that the synthetic data that we have generated mimics the characteristics of the actual data. Otherwise, your observations on the synthetic data may not correspond to the observations that you will have on a real data set. So, if you have if you have proper understanding of what kind of what is the nature, what's the nature of the real data set, and if you have proper mechanisms to mimic that, then perhaps yes, you can use synthetic data to augment the lack of actual data. So is that correct?
In addition to that, another method is something called oversampling. So when you have something like class imbalance data set or something, you can do oversampling.
Right.
So, but one interesting question, last question, but I'm not sure we have this answer or not. Does exit polls use this type of analysis? Are tools available for media houses? I have no information about this.
Yes, they have their own what is called proprietary softwares written by some big company using these, and those tools are not available to the outside world. You have to purchase the proprietary product. The media houses as they have.
Okay, so I think those are the questions.
Now, one more question we have skipped it. Skipping it, does efficiency increase or decrease having multiple hidden layers? Got it? Does efficiency increase or decrease hidden layer?
Okay, so these two we need to understand. So efficiency is about kind of computational time and say speed and so on. So if you have a more number of hidden layer, the number of parameter is going to be large. So it will take more time to compute. Whereas for the case of effectiveness, so having multiple advantage of neural network is having multiple hidden layers. You can have each hidden layer trained for some for a particular aspects. Let us say some problem need to take care of different levels of aspects in different granularity. So we can twin and set the hidden layer in such a way that its hidden layer take care of different aspects. So in that case, having hidden layer will be better performance. But however, say the cost that you are going to have from the hidden layer and the benefit you're going to have from the say more hidden layer, that has to be checked. So randomly increasing hidden layer may not be helping, but problem with deep neural model is that we do not know what is going on inside. It's like a black box. Okay, so explainability of what is going on inside is the open problem now in deep learning. So that is the one difficulty. But so we have to quite often we have to error and see how many hidden layers will be good and say enough and so on. Okay?
One more question. I think you have CNN or RNN. Which is the best for text classification?
Okay. See, again, it depends on how you want to see the text. Let us say if you are processing a sentence and your underlying problem, just like your part of speech or NER, this language identification, this kind of problem needs contextual information, like what was earlier. Okay, in such a case, you need to use say sequential based model like RNN or LSTM. But whereas in CNN, so what is actually how CNN comes up is that it started with the image video processing. So when you try to use multi-layer perceptron for image or video, the number of parameters that you need to learn is huge. So I think in one of the session I have, let us say I want to build a classifier for an image, right? Just image of 1000 by 1000 is going to need if I want to use multi-layer perceptron, when I try to represent this 1000 by 1000 resolution image, so every row the image will be concatenated, and that will be something like say 1000 into 1000 number of vector elements. Okay, that is the huge size. So in order to avoid that, the CNN was proposed, where CNN the parameter can be reduced to filters, and the filter can capture the local say localized information. Okay, so so if you look at, instead of like say some text application where you do not need this sequential information, then CNN also might be useful. In our local experiment in sentiment analysis also, many of the CNN based models are also giving very comparable performance. Okay, but CNN, we are not assuming this linear dependency in cannot be captured. So if you are looking for linear dependent problem, then you have to use the RNN or LSTM.
Okay, so the first question in this was, would it be right to say that CNN is better for image data and RNN is better for text data? I think indirectly we have given answer.
Yeah.
CNN is better for image data and RNN better for text data.
So it's not about better. Yeah, it's not about better in terms of performance. Multi-layer also might be able to do, but the number of parameters that you're going to need is huge. When even for 1000 by 1000, you're going to have 1000 into 1000 number of your feature vector is going to be 1000 by 1000, right? So, and with that, if you build a multi-layer perceptron, your number of parameter is huge. Okay, that is also one of the problems.
Two more questions added in the Q&A. Can you? Is neural network models used in spell check like Grammarly?
Yes. Actually, what happened for spell checking, Normally, I'm not sure, but if in general for spell checker, there are various methods, out of which one popular method is something called language modeling. So, model is a very good model for building language models. Okay, so yeah, neural models are heavily used in spell checkers.
Next question.
Depending upon the data set and its the model processing the model behave more accurately. If yes, is there any fixed way of data processing for each model? Yeah, I think this is we have to
Very difficult
look at
to decipher.
generalize.
No, it's not possible. That generalized concept will not come up. Obviously, all machine learning application is domain dependent, and domain plays a big role. And that indirectly data getting from the domain and finding features or metadata and then corresponding model all together. Every time we have to look into it and do it. So generic solution, I don't think we can give, right?
Yeah. So one is what is the maximum and minimum number of neurons in each layer? It depends on your problem. Say, for example, in the what will be the number of neurons in the input layer? So that will decide by the size of the vector that you are going to give. So something like when you do not use this, what is that embedding, and when you directly give input as a one-hot encoding as the input, then the number of vocabulary in your collection, okay, that number of nodes in the input layer, and the output layer depends on your requirement. Let us say you just want, I'm building for a not for a classifier, but just to estimate some real number, then only one node will be sufficient. Then if I want to build a classifier of 2 class levels, then I may be able to do that with one nodes, where say close to 0 is one class, close to 1 is another class, and so on. Or you can also have 2 nodes, one node for one class, another node for another class. So likewise, if you have your number of classes is k, then most likely you are going to have k number of nodes in the output layer. So it's all depending on the nature of your problem. Whereas the hidden layers, the number are the parameters. This is something that user need to define.
Okay, so Ranbir, Vidyut has already joined, and subsequently some other panel can also take questions related to generic, correct?
Yes.
So few more questions remain, but we will see. Okay, continue.
So with this, we are concluding this session, sir.
No. Session continue, one after another. So there is no break. I am talking about the session. Panelists are joining and we are discussing questions. Subsequently, questions participant can give any questions related to open problem or any guidance or anything new, and we are continuing this answer also. Okay.
Okay.
So a few more questions remain. How will we set hidden layer? Is there any rule through which we can identify the same?
I think we have answered this.
As such. Then coming to, sir, whether processing data sets through neural network algorithm is CPU intensive or memory intensive?
Yeah, if you are running deep neural, I think CPU is not sufficient. You have to use GPU. Okay, and it is quite often it is memory intensive because the parameters that we are talking, these are the matrices, right? So this matrix, if you are not doing, this whole matrix should be in the memory. So your RAM size also should be high. So this is both say memory intensive, but the again see all the ask what are you doing. If you try to see from the operating system perspective, you are doing you are assuming that everything is stored, parameters are stored in the memory, and you are going to do nothing but matrix multiplication. So matrix multiplication is a CPU intensive. So in that sense, it has to be CPU intensive as well. But CPU will be too slow. You have to use GPU if you want to learn, if you want to do deep learning framework with larger data sets.
I am adding a question to you. Xeon Phi is also available. Why GPU only? No one has asked. I am adding. GPU, Xeon Phi, again GPU, there are different company, NVIDIA, as well as you have, what's called, AMD. So, there is, in any case, CPU, GPU, and Xeon Phi. No one has mentioned Xeon Phi. I don't know. Anyone can answer? Ranbir?
So I think you better to give the answer, sir.
You are putting all on me. Yes, we can use CPU, GPU, or Xeon Phi. Sometimes if it is purely so Xeon Phi actually Intel box. Intel is coming up with similar to GPU, that arithmetic pro processor Xeon Phi, and there are software available to run Xeon Phi also. So this ML work. So one can look into it. What is called? I'm forgetting the technique. GPU is NVIDIA GPU is, you can go for the torch, Pi, this, all these things. Another is for Ranbir, can you help me that which
Sir, I don't have
program
much
in high
idea
level?
on that, sir.
No, programming can be written in high level, which is tiles programming. If we do the tiles programming, then GPU, CPU, and what is called Xeon Phi, all cases it will run, and you have no problem. But memory as one issue, it will remain. Okay, so next question is, what your comment about using MATLAB or other software like TensorFlow only?
So what is the question, sir?
What's your comments on using MATLAB or other software like TensorFlow only, not using the Python? That is the question, basically.
No. See, Nilaksi had used Keras. Okay, so Keras is a kind of API
No.
based.
I think you are not getting. They are telling some of the people are publishing paper using MATLAB only. That question is coming from that point of view.
Okay. So MATLAB is good for because we generally in computer science we don't use much of the this one MATLAB because of like other tools, but in images, image processing and signal processing, I think they use MATLAB very heavily. But what I understand from MATLAB, I think it is mostly for you can do this matrix algebra and so on nicely. Limiting to matrix algebra alone and some sequential processing, then I think that is all right. But I'm not sure MATLAB can support very huge dimension.
Agree. MATLAB has all features, but yes, size is a big issue. large size program running will be difficult. That I agree. Now, Amit Ayakar is also joined. So we'll put on question someone has given, that is Subha Raju, that when we go for machine learning algorithm, when we go for deep learning techniques, why ML algorithm if DML algorithm perform well? Such type of questions arises. So Amit is there. Let Amit also talk. Amit, can you speak?
Yes, am I audible?
Yes.
Okay. Yes. What's the specific question?
When we go for machine learning algorithm, when we go for deep learning algorithm or techniques, why machine learning algorithm if deep learning can perform well? Three questions,
So,
one after another.
there are multiple considerations. So first of all, you have to ask question, how much compute power you have available and what is the requirement of your application. If your application is such that you can derive the features of your data and it gives you sufficient performance in terms of accuracy or F1 score or precision recall, anything. So whatever is the requirement of your application, if the traditional machine learning methods like regression, decision trees, they give you sufficient performance, well, I don't see a reason to go to other method. Second thing is sometimes you want explainability for your method. So if you want to defend your machine learning method in a court of law, you might have to explain why your system took a decision. So in that case, you have to choose models which are explainable. Again, in that case, deep learning are not a great choice because you cannot really explain the decision of the deep learning model. So explainability of artificial neural networks is a very hot topic, but we are still not there to explain the models completely. So if you have to explain the model, something like decision trees where you can explain your decision. Another factor is that much training data is available to you. If you have a very tiny amount of training data available, then you cannot train your deep learning networks. So in that case, even if you want, you won't be able to get a good performance from a deep learning model in the absence of large amount of training data. And then is the question of availability of the hardware. So if you don't have GPU compute power available with you, you have to switch techniques that don't require GPU. The various questions you have to ask before you say that, oh, will I go for deep learning based method or traditional machine learning methods?
Okay. So any other panel member wants to add anything? Or we can shift to the area of research in social media analytics. So Amit will give. You have given already your presentation time.
Yes.
You can repeat also.
So one talk I gave, which was about the abuse detection in social media. That's one topic. So other topic which is still interesting is the spam filtering in social media, which is not exactly the harmful speech or the abuse, but it's the spam which is there in the social media. So that could be one interesting topic to pursue. So the spam in email has been pursued quite a lot, but the spam in social media is also an issue. One other aspect could be the various biases that we see in social media. But I'm not really that active in social media analytics. So I think perhaps Ranbir is the better person to answer this question.
Okay, Ranbir will come at last. Saradhi, you have anything to add?
Well, not specifically with respect to the social media, but there are governmental efforts also with respect to the social media. That's what I can actually understand. There also, one of the things is that we're as of now we're looking at users only. From the government side also, they're actually looking at the analytics part, various analytics parts. But their objectives are very, very tailored. I just wanted to say to the audience that it goes beyond the users as well. That is the limited point I want to make.
Okay. Ashish, you have anything to add? Ashish Anand.
Am I audible?
Related social media analytics analysis. Yes, you are audible.
Am I audible?
Yes.
Uh, Not much from my side. Again, I am also not so active on the social media analytics, but a few things, maybe specifically since I am interested in clinical side. So maybe the social media platforms where people talk about that is related how track social media to find out certain things like whether people are talking about adverse drug reaction or if they are talking about certain kind of diseases from what kind of information we can infer after extraction. So that could be an interesting thing. But again, I'm not very sure that how much this kind of activity or decision or sort of discussion plays in the context of the Indian population. In abroad, there are many such platforms. People make such groups and they have a lot of discussion on these aspects. But I am not, as I'm not so working on this particular.
Okay. Okay.
I'm not aware.
Okay. Vidyut, you want to add something? Vidyut Patra? Vidyut, are you there?
Hello, sir.
Can you add something? Social media analytics?
Yeah, I can focus on the something is called location-based social network. So that is not much explored.
And
so there is something called point of interest recommendation. So that can be a good research area for some guy to explore. Especially the cold start point of interest recommendation would be a good area to explore.
okay. Ranbir, now you talk, then I will talk. I will come MeitY point of view. Ministry of Electronics and Information Technology. Okay. Talk.
I probably want to put this from two different perspectives. One is from the application. So today, since the social media becomes ubiquitous, so any problem related to the social media, from good, can you please can you give
Some problem.
Some problem.
So I want to see from two sides. One is from the user's application. So since social media become ubiquitous now, I think not multiple users applications are required.
Okay.
So starting from say mental state analysis of the say users, starting from the say like communication, spam, fake, rumor detections. Like so, any application that demands, say, requires, say, social. I think that there will be application for that. So one is the application sites. So some people are working on something like, say, whether analyzing the whether selfie is dangerous or not, how many people kill with selfie and so on. Likewise, ideas people are using. So again, social media has been used for traffic monitoring in some cities. Even for the city management, social media has been used. So likewise, people have traffic monitoring, then city in the city, smart city, and so on. So various applications people have look at. So even I think one of the question one participant asked was some application on the telecom. So so I am collaborating with IIT Mandi with for the NMS networks. NMS network is kind of telecom company. So what they are asking is like say for telecom some plan, some policy, they need to predict potential traffic in future. Say when there is a festival tomorrow, how much traffic it may happen. Celebrity die, then how much traffic it may happen. Some kind of traffic prediction they want to see. Then this traffic we can also see from how much traffic coming from social media. So are there any correlation between the network traffic on the say or something, the data traffic and the some discussion on the social media. So likewise, people are looking that kind of relation as well. So I think there is a wide applications. So that is from application side. Another is side, from the theoretical aspects. So if you look at for all this application, you have to perform some specific models, classification model, clustering model, topic modeling, and so on. Many sub models you need to work. So another aspect of research aspect is on the theoretical model. So where academic people like us try to focus. So not on the application side. So like say in the network also we are say community detection, clustering, evolutions of the network, then how to represent the network in better representation and so on. So we have application for network image, video, then multimodal application of all these models. So one is the theoretical aspects, another is application aspects. So and these two are kind of very different research scope. So I think academic has a kind of wide range of possible areas. So you can supplement this.
Okay, I am giving from the MeitY point of view, Ministry of Electronics and Information Technology point of view, as well as my own point of view. See, today's and tomorrow and day after tomorrow and so on, social media will play a big role. And everything is available inside the social media. Be student, kids' behavior to the whoever is going to die, their behavior, their approach, social media playing big role. We only talked about little bit about Twitter, Facebook, and little bit WhatsApp today. Our one of the expert Firdaus has added it. Also, we have what is called blogging site Reddit. Again, we have a lot of social media inputs available, and if you go through the social media inputs from kids to aged people, from one domain to another domain to another domain to everything is available in social media in certain form. What we do academicians is link predictions, rumor prediction, fake news predictions, influencing or the finding these, community detections. We do NLP, we do a lot of things. But the need of the government of India is also to be looked into it. We talks about the power grid network, talks about the any network, whatever you can imagine. Everywhere there is option for some kind of penetrations using social media analytics. And social media not only text, video, audio, image, and everything. And what hypertext, user profile, all things are there. So Government of India is utilizing very widely the social media, learning behavior of citizen, and also how to reach to the citizen. This is one of the important topic, and ministry has a funding options. If it is security, rumor, or political unrest, or criminal activities, all such terrorist activity. One group is working, its e-security divisions is ready to pay money for projects. So you can be submit your security point of view, riot, security, communal, all kind of things which play security issues in multimodal systems, text as well as all, including user profiling. This is one options. Then you can go Ministry of Ministry. Another domain is called R&D in IT. That is information technology. We play a huge amount of projects related to social media analytics, other than security. We have other domain available is called CCBT, and CCBT is also another area where MeitY is also providing good amount of project where machine learning is part and parcel. Now, machine learning as well as social media analytics is playing bigger role from the social media perspective. It depends on who is the user, who are the people using, and if you mention one topic, the area of domain, we will find it out applicable. So machine learning or deep learning, that area. If anyone is ready to point it out area, but for example, one of your people have mentioned in question is that can we use learning this in the what is called power system? I gave answer to the power, thinking that power system network is isolated, but we can find that people are expressing their views in social media about the certain DISCO. DISCO is basically the electricity company who is distributing the electricity to the each and looking into the social media, everything, we can, the input from the different people discussion, we can find something and we can feedback to the power system people that your improvement is required here, or increase the power tariff or decrease the power tariff, all those things. So in nutshell, social media is our future. Social media is at present our everything, and learning and everything is through social media, and it's very difficult to pinpoint only one or two domain. It all domains comes into picture, and okay. Any other questions? Anyone have anything? This is from my side. Anyone wants to add anything? It's fine. Ranbir?
Yeah. And another point that I want to add might be, so lots of platforms, and each platform follows their own for, and and again, one person might be joining different say platform with different IDs and so on. So one important area for applying, for building any application, integration from across the platform. That may be that.
That's a very valid point. Very valid point.
Another is like identifying, resolving different users in different platforms. Like say identifying that this user in one Facebook and Twitter, they might be using different IDs, but identifying.
This is one research area. Very important research area with respect to identifying same identification in different media, correct?
Yeah, so this is 2 points I want to add.
And I forgot one thing. Every company in the world, they have a presence in social media, and they are doing all kind of analysis using social, and they are improving their systems. So they are delivering through social media to the customer as well as their information. They are collecting information from social media, and social media definitely is playing big role. So if anyone has any questions, otherwise each and every panel member can give their final thought, and we will close these things. We'll start with Saradhi, you have any final thought to say? Because no more questions are available. We can give final thought. One after another, we can close them.
Sir, I do not have any specific thing to add, sir. But one thing that comes to my mind is that the way this entire sessions are organized along with hands-on is really, really appreciable. With this limited point, I rest.
Okay. Then, Amit, you have anything to say final? Yes. Amit, are you speaking? Okay, we'll come back to you later. Ashish, you have anything to say final? Ashish Anand?
Am I audible?
Yes, yes. Now we can speak. No problem.
Okay. Yeah. So first of all, I would like to thank the organizers for organizing this workshop. It's a really nice initiative. Uh, about this field, the comment that I would like to make is that, see, many of us have hesitation that how to get started in research in machine learning field, and the most common impression that we have is doing research in machine learning is only about discovering new methods and new models. So discovering new methods and models is an important part of the research, but there is a lot that can contribute apart from the new models and methods. And that is something that I would like to emphasize to the participants. So if you can contribute in terms of generating the data sets, especially the data sets in Indian languages are really few and small. So if you can do something about it, that's a welcome contribution. If you can build applications which are specific to a very niche need, that is something that you can do, and that would be really appreciated. And third thing is, even if you don't have a lot of GPU power or a lot of supercomputing power available, the is the analysis of models and data sets. So these are the three low-hanging fruits that you can get started with, even without having a lot of hardware setup or a lot of funding. Okay? So that's my final thought. So if you have funding and the compute setup available, of course you can go and target more ambitious goals. But in the absence of that setup, there is still a lot that you can contribute.
Okay, thank you. Ashish? Ashish Anand? Yes.
I think there seems to be some network issue with Ashish.
Okay, Vidyut. Vidyut, go ahead. Vidyut, sir. Can you say something, Vidyut?
Hello, sir.
Say final word, whatever you come to say.
Yeah, no, maybe this might be a question to all others. So, because at social media is so important nowadays, so how do you link the social media with the, say, different learning analytics or learning platform? Let's say Coursera or maybe some other way, so or in PTL or so. So, how do you link it?
That's a good thing. Participant do research. Okay. Ranbir, you want to add it, or you are the last?
Sir, I am done, I think, sir. Ashish, we can ask once.
Ashish, you can you say something? Vidyut, you mute. Vidyut, you mute. Okay. So, one person has mentioned that civil detections. See, civil or civil research is basically spoofing, one kind of spoofing. And this spoofing detections is very easy or depends on the domain. And it is part and parcel of every domain, including the social media. Specifically, I can spoof at someone and do something. It is also called civil attack. So this is obviously one of the important topics in social media. In any case, the course we have to end it now. So at the end, I want to thank everyone as everyone has their feedback as well as this feedback. At least ISEA PMU will get the feedback from all of you. Please give your feedback. That is one. Second thing is we'll put up our all things by within few days. The open source intelligence lab network, that websites, all things you can download and study. There will be a quiz for those who interested to get the certificate. You have to pass through one quiz, and that will be arranged by I. So in subsequent time, they will contact you. Obviously, social media is a multimedia. Multimedia as well as incomplete from my point of view. My knowledge in social media incomplete. Similarly, everyone's knowledge. So incomplete learning informations, several people together can make a more complete informations in multimodal way. So research in social media, application in social media, including the building some product which Atman very, very important. Self-reliant and sustainable India is very, very important. Whoever is ready to collaborate in social media analytics, please give your input to ISEA PMU or to us. There is option for ISEA phase 3. In ISEA phase 3, obviously social media analytics will be one of the important part, and the collaborative research will be there and good amount of funding will be there. We hope all of you, all participants, all panel members will participate in the future ISEA phase 3. With this, I, on behalf of the organizer, thank you all and be available for in future participating in any. Thank you.
Sir, I just want to add supplement one.
Okay.
So I want to thank